it's just kept.
Yes, it is like some, but now it's too late to. So how to, can you help?
Any Apple boxes like.
What is Apple box?
Kind of.
What is it?
Extra box.
So, check. Good morning, ladies and gentlemen. It gives us immense pleasure to welcome you all to the Underwater Robotics Workshop UWR 2026, organized by National Institute of Ocean Technology under the Ministry of Earth Sciences, Government of India. We extend a warm welcome to our distinguished dignitaries, senior officials from strategic and defense organizations, scientists, academicians, industry leaders, innovators, researchers, students, members of print and digital media, and all our sponsors.
Over the next 2 days, this workshop will bring together experts to deliberate upon future technologies, challenges, and collaborative opportunities in underwater technologies. May we now commence the inaugural function.
I respectfully invite our distinguished dignitaries to kindly grace the dais. Our esteemed chief guest, Vice Admiral Biswajit Das Gupta, National Maritime Security Coordinator, National Security Council Secretariat.
Rear Admiral T.V.N. Prasanna, Joint Secretary, National Security Council Secretariat.
Dr. M.V. Ramanamurthy, Mission Director, Deep Ocean Mission.
Professor Balaji Ramakrishnan, Director, National Institute of Ocean Technology.
And Dr. S. Ramesh, Deputy Director, National Institute of Ocean Technology. May I request our esteemed dignitaries to kindly take their seats on the dais.
Thank you, sirs. Now may I request Professor Balaji Ramakrishnan, Director NIOT, to welcome our chief guest, Vice Admiral Biswajit Das Gupta, with a bouquet.
Thank you, sir. I request Dr. M.V. Ramanamurthy to welcome Rear Admiral T.V.N. Prasanna.
Thank you very much, sir. May I again request Director NIOT to welcome Dr. M.V. Ramanamurthy.
Thank you, sir. I request Dr. S. Ramesh to welcome our Director. Thank you, sir. To invoke the spirit of patriotism and seek divine blessings for the successful conduct of this workshop, may I request everyone to kindly rise for the rendition of Vande Mataram, followed by Tamil Thai Vazhuthu.
Vande Mataram, Vande Mataram, Sujala Suphala Malayaj Shitala, Sasya Shyamala Mataram, Vande Mataram, Shubhra Jyosna Pulakitayamini, Pullakusumita Drumadala Shobhini, Suhasini Sumadhura Bhashini, Sukhadam Varadam Mataram, Vande Mataram, Vande Mataram.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் வதனமென திகழ்வரத கண்டனிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு இறை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறந்தியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Thank you, sir. Tamasu Ma Jyotirgamaya. May I request our esteemed dignitaries to kindly proceed for the ceremonial lighting of the lamp and guide us from darkness to light. Please.
Thank you, sir. May the light of knowledge continue to guide our efforts towards advancing underwater technologies, ocean sciences, and national capabilities.
Every successful institution is guided by a vision, and every vision is translated into reality through leadership. As we begin this workshop, it is most appropriate that we hear from the institution that has been at the forefront of India's underwater technology journey. It is now my proud privilege to invite a visionary leader and the driving force behind several pioneering initiatives at NIOT, Professor Balaji Ramakrishnan, Director NIOT, to deliver the welcome address and present the underwater robotics vision. Over to you, sir.
Chief Guest, National Maritime Security Coordinator, Honorable Vice Admiral Biswajit Dasgupta ji, Rear Admiral Prasanna ji, VSM Joint Secretary NSCS, my dear colleague, mentor and well-wisher, Mission Director Deep Ocean Mission, Dr. Ramanamurthy garu, my dear colleague, Mr. Dependable, Deputy Director, Mission Projects Management of NIOT, Dr. Ramesh, invited speakers, distinguished experts from academia, research institution and industry, students. So there are about 100 students gathered behind this hall. This hall has a capacity of restricted only to 200. So we have 100 students actually gathered here. They define the future of our country. They always address them future of India. Sponsors, media personals, ladies and gentlemen. A very warm good morning to all of you. It gives me immense pleasure in welcoming you all to this National Underwater Workshop, Robotics Workshop, a unique 2 days technical program to share knowledge and exchange ideas on the underwater technological domain. We are delighted to have participants from across the country representing academia, industry, R&D organizations, underwater technological users, various stakeholders have assembled here today. We believe that this is a new beginning and the outcome of this workshop would help us in drafting a roadmap for a larger framework and coordinated efforts in the development of underwater robotics in our country. With more than 3 decades of relentless, illustrated, and successful R&D efforts in the field of ocean technologies, NIOT, we believe, is the right place to organize workshop of this kind. And I'm very happy to welcome you all to this unique institute that focuses on sustainable technological development to harness marine living as well as non-living resources. With more than 2 million square kilometers of exclusive economic zone, comparable to the area of the landmass, India's blue economy potentials are so huge, so much so that even a small fraction of the same is tapped effectively. I'm sure our nation's GDP would rise to a new heights. Living resources, we talk about fisheries, seaweeds, deep sea aquaculture, marine microbes to medicines, and then we have non-living resources. We generate water, potable water from the oceans. We generate electricity from marine renewable energy sources. We tap minerals. We talk about shipping, ports, shipbuilding, coastal tourism, many, many more of these potential we are talking about. With a limited understanding on the marine resources, in fact, the actual blue economy potential of our nation is yet to be completely estimated, in my personal opinion. There is a say in our language, Tamil, Katrathu Kaiman Alavu, which means any human's knowledge through learning process has always been just a handful of sand in their entire life. If that's the case, when it comes to the learning and knowledge about the marine resource potential, it's just one single sand grain in the handful of the sand we are talking about. We need wide range of ocean technologies, including surface and subsurface autonomous systems, even to estimate and to understand the quantum of blue economy potentials within our EEZ. The workshop precisely aims to identify technology gaps, promoting indigenization, assessing industry readiness, understand the requirements from users and other stakeholding agencies, and to evaluate infrastructure requirement in the country with a view of national framework on underwater robotics. In addition to this, my dear friends, NIOT has not only been the pioneer, but also in the forefront of capacity building in the field of underwater autonomous systems. I'm sure you would be aware of the fact that we have successfully organized a series of students' autonomous underwater vehicle competition. It's called SAVE, straight from 2011 to 2019, where NIOT has actually funded 6 winning teams to attend global underwater autonomous competition in USA that promoted, to be honest with you, 2 interesting startups in this company. I don't want to name them, but I think probably you will come to know very soon. After a brief pause, NIOT has come back again to organize the SAVE competition starting from this year onwards with the 2 different objectives, 2 different winning teams. One goes to USA with the funding support from NIOT, and other gets seed grant R&D funding and opportunity to work with us. Yes, one team goes to US, the other team comes to us. Our motto for the young students is come, compete among yourself, celebrate the winning, and then collaborate with us actually for the way forward. Even in this workshop, 2 days workshop, NIOT has actually opened great opportunity for young students to showcase their talents through poster presentations and live underwater model demonstrations with the chances of winning lucrative cash prizes. Yesterday, this institute has witnessed the surface vehicle maneuvering competition amongst the student generations. 26 teams have participated, 6 chosen for demonstration, and 3 are going to win the prizes. I am also taking this opportunity to quickly go through NIOT's accomplishments, current developments, and future plans in the underwater technologies. Can I have the slides? Yeah, thank you. In the interest of time, I will skip this. I will straight away go here. Established in the year 1993, we are completing 33 years of service to the nation through science, engineering, and technological development. NIOT has grown by leaps and bounds with its headquarters in Chennai, this very campus where we all have gathered here today. We have 2 more campuses in Andhra Pradesh, one of which is very interestingly has got a seafront of about 150 acres. We have yet another campus in Sri Vijayapuram, erstwhile Port Blair in Andaman. And my dear friends, as we speak, Government of Odisha and Lakshadweep administration are seriously considering in allocating field stations for NIOT with their respective states. NIOT has recently transformed itself to a new avatar and geared up to take more challenges. We are now ready to face any mission mode projects as well as the continuing operational programs of the ministry. New verticals that consolidate and combine the strength of this institute. Our young scientists who would be serving beyond 2047 has drafted a beautiful Vision 2047 document of this institute with a large number of ambitious projects. In fact, when I spoke to them, they said, with the heads high, sir, this may look ambitious, but very much doable within 2047. All of this is actually inbuilt in our vision document, and anybody is interested in actually they can visit our website to get the published document 2047 available at their disposal. And in all our R&D efforts, they follow the United Nations Sustainable Development Goals. And you can see the picture at the bottom basically tells you the range of UN's SDG goals that we address through our R&D programs. As we all know, NIOT has actively been in the development of a 6,000 meter rated human submersible under the Deep Ocean Mission program Samudrayan, the design of which is entirely in-house. Designed for 3-member crew with a mission endurance of 12 hours, the system is targeted for 500 meter deployment on a pilot scale by this year 2026, and ultimately for 5,500 meter deep ocean operations by 2027. There are at least 10 distinct technological futures that places our Matsya 6000 on a different pedestal of global human submersible map as the 4th generation category. Our team can narrate all of these details of 10 distinct technological futures anytime that is really required. Our team is also working on a human-occupied subsea observatory for underwater research and long-term monitoring applications, and the conceptual design has already started actually brewing up inside the campus. And another mission submersible, manned submersible with enhanced viewing capability is also in pipeline. These efforts represent India's growing capability and self-reliance in deep-sea technologies, supporting scientific explorations, strategic applications, and the future of blue economy. Our journey, NIOT's beautiful journey, began around 2010 in the development of deep water ROV systems, where the primary focus of our team was on the hydrostatistics, hydrodynamics, structural integration, and field testing. These efforts established the foundation for deep sea technologies in our country. Polar and shallow water ROV with enhanced capabilities in communication, navigation, and control systems suitable for harsh marine environment was also developed in the later stage. By 2021, the focus shifted towards autonomous underwater vehicles, AUVs, integrating underwater survey systems, image processing, and acoustic telemetry for autonomous ocean operations. At present, our team's major development are centered around the Matsya 6000 program and advanced underwater technologies such as high energy batteries, buoyancy systems, digital twins, human support systems, and underwater autonomy. The upcoming phase targets AUV homing and docking technologies. Our team has already started working on it. Wireless power transfer, underwater data transmission, and AI-guided autonomous operations for long duration missions. Looking ahead to 2028 and beyond, we aspire to develop 6,000 meter rated deep water autonomous system with enhanced endurance and intelligent mission capabilities. Further into the future, swarm AUV technologies with a decentralized, cooperative control and bio-inspired smart underwater vehicles powered by fuel cell technologies are envisioned by 2035. This roadmap, we believe, not only represent technological advancement, but also strategic move towards indigenous capability development within the country, smart ocean exploration, and sustainable blue economic growth. NIOT is currently developing Trinetra 100, a compact autonomous underwater platform designed for surveys and intelligent mission operations. Tirel 300 is an advanced modular AUV platform developed exclusively for enhanced endurance, navigation, and payload integration. To support long-term autonomous missions, we are developing Shakti 100 docking station for underwater docking, charging, as well as data transfer, which is a critical technology for present ocean operations. Another important development is the OIL 6000, a 6,000 meter rated AUV designed for deep sea exploration and scientific missions. The system integrates advanced navigation sensors, pressure resistant structures, acoustic communication, and modular payload sections. Our approach in all of these efforts remain the same 4D philosophy. We would like to design, develop, demonstrate, and deliver to the society with a strong emphasis on the indigenization, autonomy, and future-ready underwater robotic system. The key strength of NIOT is our fleet of technological research vessels, which enable offshore deployment, testing, and ocean observations, and deep sea operations. But we believe, sir, that the nation requires more state-of-the-art research vessels for deep sea explorations as well. And the kind of research vessels right now we have, I think it has to be, enhanced to cater into the deep sea explorations continuously. In addition, NIOT houses globally recognized acoustic test facility, a very unique facility in the country that supports our calibration and validation of underwater acoustic sensors, communication systems, and sonar technologies. Hyperbaric test facility, which is capable of testing up to 900 bar pressure, a very, very unique the facility, which will soon be upgraded to 1500 bar, and state-of-the-art integration bays are also available at our disposal in the campus. NIOT is currently working on the development of multiple unique infrastructure in our various campuses at various stages of progress. So we are planning to have a deep ocean simulator, DOS 900, where we can test actually full system, entire system, bigger than actually what we have right now, the simulator. Establishment of a national deep sea technology integration bay, which is a special ecosystem that we would like to develop, and that will help us in continuous strengthening of indigenous deep sea technology ecosystem in the country. And these facilities are going to be coming up very soon. As we all aware of the fact that underwater robotics is not built by a single organization like NIoT, just NIoT, but through a strong ecosystem of collaborations among academia, R&D institutions, industries, startups, user agencies, and policymakers. Some of our collaborators have been mentioned actually here. Our vision is aligned with Atmanirbhar Bharat, focusing on indigenization towards blue economic growth, ocean explorations, industry development, and global leadership in the ocean technologies. The roadmap ahead of us demands innovation, collaboration, sustainability, and continuous human resource development. Together, we can transform India into a global hub for underwater robotics and smart ocean exploration. Once again, I warmly welcome you all to this national level underwater robotics workshop. I hope you will have a pleasant, fruitful, and enriching stay at NIoT. Our organizing team will be happy to assist you with any support that is required related to the workshop and associated activities. Sir, there are two things that connect all of us gathered in this auditorium. One is the nation, and the second one is ocean. Interestingly, both are printed in our institute's name, National Institute of Ocean Technology. Thank you, and wish you a wonderful experience at UWR 2026. Jai Hind.
Thank you very much, sir, for establishing NIoT leadership in underwater technology, Ocean for the Nation. It is my pleasure to introduce Dr. M.V. Ramnamurthy, Mission Director, Deep Ocean Mission, and a distinguished expert in coastal and ocean engineering with extensive experience in desalination, offshore wind energy, coastal hazard management, and marine ecosystem conservation. He has led several high-impact national projects. His contributions have been recognized with the Ocean Technology Award in 2021 for outstanding work in ocean and coastal research. May I invite sir to deliver the special address.
Very good morning to all. Honorable Chief Guest, Vice Admiral Biswis Dasgupta ji, and Rear Admiral Sri Prasanna ji, Dr. Balaji, Director NIoT, and Dr. Ramesh, colleagues from NIoT and various institutions, most importantly students and also from the industry. Very good morning to all and welcome to this important two-day workshop on that. Actually, Professor Balaji has mentioned about importance of NIoT role and then what need to be done for the future. In fact, this particular workshop has started from, I should say, thanks to Prasanna ji. When we had a meeting at his office, he was telling how do we take and strategize this underwater robotics in a big way and utilize expertise of all the institutions also in the industry in one single platform. That was the start point. I think now it has come to the reality, and I personally thank Vice Admiral also sparing his time and coming here all the way from Delhi and spending for the 2 days with us. So basically what we would like to do is, I think as a part of the Deep Ocean Mission, under the vertical one we have two major components, three especially, in fact three. One is on the manned submersible, human submersible which is being built by NIoT. Second one is on the deep sea mining. Third component is underwater robotics. In fact, it was on the very low phase in the initial stage. Now it has taken its own full shape. I think today we are going to inaugurate that center also as a part of that. In fact, Mr. Prasanna ji was asking about only virtual center to be developed, but I think Dr. Balaji has taken initiative to have a physical center also at this particular place for that. Now we all know that underwater robotics plays a very vital role, especially in mapping of the ocean, not only on the mapping but also on the rescue or even national security, including new science areas can be discovered from there. A lot of unknown areas can be mapped with underwater robotics for that. For that, what we need to have a stable platform and also good collaboration among the national institutions. In fact, under the Deep Ocean Mission, we have already sponsored some projects related to various institutions like some of the IIT Chennai, IIT Guwahati and IIT Rupar, but also many other institutions. I think in fact SRM and then VIT from the local institutes are also a part of this whole initiative for that. Now it is only the time to integrate all those things and take it for the actual utilization for the civil society, also for the national security. I am sure that this particular 2 days conference will build a new insight and collaborative efforts among the stakeholders, and also to take it forward in the big way where we will be in a position to develop systems for the country's benefit. In fact, when I have visited a SCIPSU Institute of Oceanography, with a small group of 4 or 5 people, they are developing AUs and ROVs for that. But why NIOT cannot do for that? In fact, this initiative is going to be one of the important initiatives for the country, mapping of the ocean floor, and also to discover many resources from the ocean for that. And I am confident that next 2 days you will have more interaction, and then also to provide a more insight into this underwater robotics area. This is one of the niche area for the NIOT to take up in the future for that. I thank for this opportunity, for sharing the experience and what has been done as a part of the deep ocean mission. Thank you.
Thank you, sir. It's my privilege to introduce Rear Admiral TVN Prasanna, a Vasisht Seva medalist and a distinguished navigation and direction specialist commissioned into the Indian Navy in 1991. With over 17 years of operational sea service, he has held key command and staff appointments, including command of INS Kirpan and INS Jalashwa, India's only landing platform dock. May I now kindly invite Rear Admiral TVN Prasanna to deliver the introductory address.
The NMSC, Secretaries, Professor Balaji, Director NIOT, other directors, subject matter experts, representatives of the Indian scientific organizations, industry, academia, distinguished guests, both online and offline, students, ladies and gentlemen. Good morning. At the outset, thank you, Professor Balaji, for giving me this opportunity to deliver the introductory remarks. My compliments to all of you too for taking the time out and joining this workshop, and I'm looking forward to your keen participation. We are all aware that the oceans are the next frontier of mankind, and they are a means for survival and sustenance as well as for national prosperity. With every passing day, the nations are turning to the oceans for their every deed, and an undeclared race to beat others in this domain is taking shape. In the recent years, India's maritime consciousness has witnessed an upward trajectory, and the maritime domain is receiving national importance. The government of India is keen on moving forward to harness this maritime potential, and it understands that this domain is a significant contributor to its GDP. Therefore, it has a direct relation to the national security as well. The technological evolution in robotics sector, use of AI, ML tools, and more importantly, employment of the unmanned systems is assuming center stage. A lot of lessons are being learned, especially so from the UAV ecosystem or the unmanned aerial vehicle ecosystem. There, the growth has been haphazard, however exponential, but there have been no system in place to vet or rationalize the qualitative requirements of the multiple users operating on the near similar environment. This has resulted in less of synergy and more of work in silos. Every user organization is individually pursuing or inducting unmanned aerial technology. Further, a dedicated strategy or a policy guidance specifying manufacturing standards, rationalizing the requirements of multiple users, or mechanism to share information between stakeholders is also lacking. Coming to the underwater domain, which we are discussing today, the challenges are almost similar, such as no major policy, research being undertaken in silos, and no manufacturing standards or minimal user interface. In addition to the huge cost implications, being the testing area, being the sea and the ocean, and the complex operating environment, which is much more complex than the air domain. Our current ecosystem lacks the benefit of pollination between stakeholders. Therefore, policy guidelines or a roadmap to bridge the gaps by providing guidance to standards, joint development of underwater technology, testing and trials of prototypes, and more importantly, establishing a self-sustaining ecosystem promoting Atmanirbharta is essential. A number of these issues were discussed in the underwater robotics domain at NSCS in January this year with a number of stakeholders. And post deliberations, the establishment for the start of a discussion forum under the chairmanship of the National Maritime Security Coordinator was approved at the highest level. And the conduct of this workshop was one of the decisions taken at that meeting. The oceans are too vast, too complex, and too consequential for any single entity to understand and manage alone. Bringing together all stakeholders, that is the scientists, engineers, policymakers, industry, defense organizations, academia, government representatives was a critical and essential requirement. Therefore, this workshop, these 2 days, that is today and tomorrow, will mark an important chapter in the future of underwater robotics. All stakeholders are here under one roof with an intent to deliberate, discuss and find opportunities and ideas to put together a better and a self-sustained ecosystem in the field of underwater robotics. I would like to wish all the participants of the workshop the very best outcomes through your professional interactions, and once again my thanks to Professor Balaji and Team NIOT for their efforts in making this event possible. Let's have a fruitful workshop. Thank you and Jai Hind.
Thank you, sir, for your words on growing strategic significance of underwater technologies. It's my privilege to introduce our chief guest, Vice Admiral Biswajit Dasgupta, the National Maritime Security Coordinator and the National Security Council Secretariat, and former Commander-in-Chief of the Navy's Eastern Naval Command. He has served the Indian Navy with distinction for 4 decades. During his illustrious career, he commanded 4 frontline warships, including the aircraft carrier INS Virat, and held several key leadership appointments across operations, training, personnel management, and strategic command. A recipient of Param Visishta Seva Medal, Ati Visishta Seva Medal, Yuddha Vishishta Seva Medal, and Vishishta Seva Medal, he currently provides apex-level guidance and coordinates maritime security efforts among stakeholders across the nation. I kindly invite Vice Admiral Biswajit Dasgupta to deliver a talk on India's strategic vision. Sir, please.
Good morning to everybody. It's a great pleasure to be here. I will start with a few layman comments before I paint a bigger picture of what our strategic vision should be in the maritime domain. You know, if God wanted us to live underwater, God would have made all of us fishes. So, since humans don't live underwater or don't live at sea, the focus is largely very land-centric. And therefore, efforts at developing the oceans and developing ocean technologies and various other things related to the oceans have been typically very slow. Now, if we talk about underwater technologies and various other things, let me also talk about, for example, air-independent propulsion. Every fish in this world has air-independent propulsion. We are still struggling with the technology. Another observation that I have is that when you start from the air and come to the surface and go below water, everything slows down. You know, from speed to communications to development of technology, it slows down drastically. So there are tremendous number of challenges that are associated with the underwater domain. And that is, I think, one of the reasons why the underwater technology, the ocean technology, has not proceeded as quick as several other domains. The sailfish is the fastest fish in the world. It navigates at 30 to 50 miles per hour underwater without nuclear propulsion. And here we have the best technologies in the world with nuclear propulsion, and they are barely touching 30 knots underwater. Underwater technology, how long earlier do you think it has been in existence? The heights of underwater technology. If you go back to Indian mythology, what was the first avatar of Lord Vishnu? The Matsya avatar. That means as long as our consciousness has been existing, there has been underwater life, and there has been all kinds of underwater technology. And here we are in the middle of the 21st century struggling with the basics of underwater technology. So it requires a strategic vision. There are countries which have done better than us. You know the countries that I am talking about. The technologically advanced nations have done much better than us as far as this area is concerned. But I think it is time for us to also up our game. As we have heard, that, the maritime environment is gaining more and more importance as days go by. So I would like to firstly thank the Director NIOT, Professor Balaji Ramakrishnan, for getting all of us together here and giving us a chance to discuss these matters and see what direction our country needs to take, not just in underwater robotics, but overall in the maritime domain, in the maritime scientific domain. So the exponential growth of everything in the maritime domain is something which is called the blue acceleration. You might have read about it. The blue acceleration is that over the last 20 years or so, every endeavor that has been associated with the maritime domain has evolved and increased exponentially. Whether it is offshore exploration, or whether it is tourism, or whether it is security, or whether it is trade, anything to do with the maritime domain has increased exponentially. And there is no indication that this is going to reverse in the near future. So the vast areas that we have above water and underwater remain untapped, and there is immense potential for research, for technology, for manufacturing, for business, for jobs, for employment, everything that you can think of. The oceans are limitless in terms of the potential that they have. And quite rightly, the government of India has launched several initiatives in this direction, from shipbuilding to risk management to addressing pollution and various other things. Now, why I tell you all this is that the reason that we are sitting over here today is that underwater technology, or underwater robotics, underwater vehicles, underwater sensors are perhaps one of the greatest enablers of all these developments. And if we are able to harness this potential correctly, I think we will be able to harness the wealth of the oceans and the potential that the oceans have for human benefit. We've heard the director of the Deep Ocean Mission telling us things. We also heard the director of NIOT telling us many good things that have happened in this direction. And I'm sure we will hear more about it from the people who want to speak today and tomorrow. So let me touch upon a few strategic and security concerns. One is that maritime threats are increasing rapidly. And therefore, in every aspect of maritime endeavor, there is some threat or the other. Even in the underwater domain, there are several areas where there are challenges and threats. We have offshore exploration, we have deep sea exploration, we have undersea cables, we have our offshore platforms, we have various other things. And where there is a great contribution of the underwater domain, there is a great potential for underwater technology, and there are also security challenges. In the defense and security area, submarine operations, underwater domain awareness is something which is a matter of very important discussion in the strategic circles today. You know, people talk about the blue economy. What is the blue economy? The blue economy is nothing but your country's economy enhanced by the oceans. That means how blue is your economy is the right question to ask. Every country has an economy, but how blue is it? How much have you involved the oceans in that economy? How much benefit are you deriving from the oceans in the overall economy of the country? So bluing of the economy is conceptually clearer than a blue economy. So as far as that is concerned, you are aware that the resources on land are depleting. The world's population has crossed 8 billion. Land resources are inadequate to cater for the future. The population is going to touch 10 billion by 2035. And therefore, unless the wealth of the oceans are harnessed in a sustainable manner, the future is grim for humanity. And therefore, the importance of the oceans, the importance of technology that we can use to harness the oceans and related aspects. Now, we have done reasonably well in the development of underwater vehicles, as Professor Balaji has told us, but there are still several challenges. And we have to see where the world has gone in technology and where we stand. What is it that we are dependent upon outside countries to help us? Among those things, what is it that we can try to develop ourselves with partnerships with academia, with friendly foreign countries, or with other agencies, innovators, scientists, professionals in the field? How can we do a little better? Another thing is that underwater robotics technology has its own challenges. Firstly, it is very expensive. There are no economies of scale. Technology is very, very high-end, not easily available. There is not enough research being done in our country for underwater technology. In fact, ocean engineering, for that matter. I would like to suggest that we must have dedicated maritime, ocean research, underwater research, oceanic research universities. If not one, at least a few of them in the country, to harness all these aspects. There are a handful of, bright sparks, one being NIOT. There are certain other universities in our country which have departments of ocean engineering. But I think this is one area which can be sort of aggregated much better. If we had a couple of ocean universities in the country, I think it would provide greater focus. It would provide a greater direction to young people who want to develop themselves in this field. It would create job opportunities, it would create ideas, it would create a lot of human capital. Marine survey, marine scientific research is something which Professor Balaji touched upon. I think it is high time we have a very, very capable scientific research fleet. We are one of the largest countries in the world. We are a developing nation. We have a lot of interests at sea. We have 1/6 of the world's population to feed. And with the dependence on the oceans, if we do not have a credible maritime scientific research fleet, one, we shall not be able to exploit the oceans to the extent that we wish. We will have outsiders coming in and doing that here. And we will lose the opportunity to provide this expertise to countries in our neighborhood. And that vacuum, that strategic space will be filled up by somebody else. So, what is the way ahead? I think we need to get our minds clear on what we want as an underwater robotics framework or a strategy for this country. What are the kind of technologies that we require? What are the resources that we require? What are the capabilities that we require? What kind of coordination do we require? How do we want to develop our human capital? What kind of engineers do we want? What kind of operators do we want? What kind of academic research do we want? How do you want to encourage the industry? How do you want to encourage the innovators? How do you want to encourage the startups? How do you want to develop your simulation and testing infrastructure without running to foreign countries every 6 months? How do you want to handle your data? Data is the foundation for everything else. If there are hundreds of agencies collecting data, where does the data go? How does it get collected? How does it get collated? What kind of protocols do you require? Can you share that data? Who's going to do the analysis? What kind of distribution do you want that data to happen so that people can use it effectively for national good? Thereafter, how would you like to govern the oceans? What kind of policies do you require? What kind of governance do you require? What do you need at the apex level? What do you need at the state levels? What do you need at the professional levels, at the industry levels? So, I think it is time to think very, very seriously about all these things in a holistic manner. Each of us have been doing our jobs very well to the extent that we can, to the extent of knowledge that we can, but I think there is room for more synergy, there is room for more talking to each other, there is a need for greater aggregation, and there is a need to see the future. There is a need to have a common vision that 20 years from now or 30 years from now, what is it, where is it that we see India's ocean engineering going? Where do we see India's ocean exploitation going? Where do you see underwater robotics going as an enabler of all these things? So I think that is what should be our larger aim when we are talking about a strategic vision. It is my intention to have this discussion forum on underwater robotics, for which I have been charged by the National Security Advisor, to have a discussion periodically. I don't know what periodicity, maybe 3 months, maybe 6 months, I really don't know. We will discuss it. I'll come to know after the day's proceedings tomorrow, that what is it we need to discuss, where do we need to focus, how do we need to break down our discussions, and how often do we need to have this, so that everybody is under one roof, try to understand each other, try to see what the strengths, opportunities, and future is together. So that is the intention. Intentions are very good. Now intentions are only as good as we collectively make it. And I really hope that this is a good start point, and we only proceed further and higher, deeper from here. Thank you very much.
Thank you, sir, for your insightful address which has provided a strategic roadmap, and it inspires us to accelerate the underwater technology development at a higher pace. As a It's apt time to release the abstract volume of the workshop. May I request our dignitaries to kindly release the abstract volume of the workshop. The volume brings together valuable research contribution, innovative ideas, and technical advancements being presented in this workshop. Thank you very much, sir, for releasing the volume.
Thank you, sir. As a mark of respect and appreciation, we shall now felicitate our distinguished dignitaries. I request Professor Balaji Ramakrishnan, Director NAOT, to felicitate our Chief Guest, Vice Admiral Biswajit Das Gupta, with a shawl and memento.
Thank you very much, sir, for your gracious presence and inspiring us. May I request Dr. S. Ramesh, Deputy Director NIOT, to felicitate Rear Admiral TVN Prasanna. Thank you very much, sir. Your presence inspires us.
Thank you, sir. I request Dr. S. Ramesh to felicitate our Director, Professor Balaji Ramakrishnan.
Thank you very much, sir. I thank all the dignitaries on the dais for their gracious presence. May I now request all the dignitaries and invited delegates to kindly proceed in front of the auditorium for the group photograph, followed by inauguration of Underwater Robotics Workshop exhibition and high tea. The high tea for the dignitaries, delegates, and group directors will be arranged in Rajendra Chola and for NIOT staff at Manthan Hall. Thank you very much.
Participants are kindly requested to reassemble here by 11:25 a.m. for the session 1 on subsea vehicle technologies. We look forward for an exciting technical program ahead. Thank you.
Thank you, K. Amuda, for this introduction. And it's an honor to be here to chair this session. I am deeply privileged to be here on behalf of the organization NIoT. We have our first session titled as Subsea Vehicle Technologies, and we have speakers from CSIR, CMERI, NIoT, Indian Navy, as well as IIT Bombay. So these four speeches are planned in this. We will have 15 minutes for the speakers, followed by 4 to 5 minutes of question answers. We'll be putting one bell before the 2 minutes of the session getting over, and a final longer bell when the 15 minutes gets over. We expect speakers to follow the timing, and audiences to have the question answer or mention their discussions after the session. So I will begin with the session now. The first speaker is Dr. S. Nandi. He is the Scientist G and Head of Underwater Robotics and Autonomous Systems Group at CSR CMERI Durgapur. Dr. Nandi has obtained his PhD from IIT Kharagpur. Nearly 3 decades of experience in robotics and autonomous systems, he has made significant contributions to the development of autonomous underwater vehicles, remotely operated vehicles, and high-endurance underwater robotic systems for various national missions. His research interests include underwater robotics, manipulator dynamics and control, mobile robotics, sensor fusion, and non-homogenic system. He is currently serving as PI for several projects under the DOM and other strategic underwater robotic programs. He has authored 55 publications, holds multiple patents and copyrights, and has guided numerous students for undergrad, postgrad, and doctoral researches. His contributions has been recognized through prestigious honors, including the DAAD Fellowship and Gandhian Young Technological Innovation Award. We are privileged to have Dr. Nandi with us today to share his experience and insights in the field of underwater robotics and autonomous system. Please join me in welcoming Dr. Nandi for his presentations. Over to you, sir.
Yes, it's okay. Hello, very good morning to all of you, and myself, Shambhunath Nandi. I am working as a Scientist G at CSIR Central Mechanical Engineering Research Institute. It is one of the premier lab who are doing mechanical engineering research as well as research in other directions, particularly multidisciplinary research. We are doing at CSIR CMERI, starting from underwater robotics, then energy-related research. Then we have agricultural research, tractor development, Swaraj, and other things also. It takes place from CMERI Durgapur, and it creates green revolution at that time in 1974, and it was inaugurated by the then Prime Minister, Mrs. Indira Gandhi. So currently, CMERI is working in the domain of underwater robotics for around more than 20 years, and I will be talking about unmanned underwater vehicles. So before that, I want to honor, Honorable Session Chair, Professor Sharang, then Honorable Co-Chair, Madam Ombudi, and distinguished guests, and other speakers, students, dignitaries. Okay, so let me start my brief presentation. The time is very short. Within that, I want to bring that development in the domain of underwater vehicles, what Indian scenario, global scenario, and how CSIR, CMERI, and other indigenous, other organizations in India, they are contributing in that domain. So, slide is not changing. Please. Yeah. So,
Yeah, so why underwater robotics, this kind of research is very important, already delivered by our, during the inauguration sessions by the several distinguished guests. So that we have a huge coastline, more than 7,000 kilometer, and also the land area is also becoming less and less day by day due to population increase. So we want to harness the ocean resource and so that it can help the human being or human mankind to understand and to utilize it wisely. So the fact is that scientists know more about the surface of the moon than the depth of the ocean, and the development took place in this way. So there are ships, submarines, manned submersibles, remotely operated vehicles, then autonomous underwater vehicles, then unmanned underwater vehicles, and all this. So if you see that unmanned underwater vehicle, what are the present status? So these are normally, termed as remotely operated vehicle. So it is connected with tether, and that tether, it carries the power and signal both. So it is just like umbilical cable, which is being used to feed the, kids when the kids are at the womb of our mother. Okay. So that's why it is called umbilical cable. It is connected with the umbilical cable, and if you want to inspect something remotely from a distant place, then it will be required to utilize the ROV instead of autonomous underwater vehicle. Second one is AUV, that is the autonomous underwater vehicle. It is an untethered pre-programmed system for large area surveys and reconnaissance. It navigates autonomously using onboard sensors and mission algorithms. So this is a more challenging thing. So here, energy system as well as onboard intelligence, both are embedded inside the system itself. And current trend is not only, to inspect the underwater systems or infrastructure or carry out some monitoring in underwater environment. There are some strategic needs. So that's why only 6-7 hours duration or maybe 15 hours duration of an AUV mission time is not sufficient to cater the need of our country. For the strategic needs, as the current underwater warfare is also propagating at a very larger scale, this is the right time to develop autonomous underwater vehicle for Indian defense on security purpose, which can cater the need of 15 days or 30 days or more. The endurance, particularly the endurance, should be higher than 15 days or 30 days, even a month. So that kind of need is requiring all stakeholders, including the academicians, research institutions, other research laboratories, and the users together, and that is creating a ecosystem how to go ahead forward and how to make our India a self-sufficient in the domain of ocean engineering, naval architecture, as well as development of extremely high endurance autonomous underwater vehicles. So this is the primary market drives: naval modernizations, offshore economy, technology leaps, and key market trends are in the area of segment shift. Particularly AUVs are the fastest growing segment due to improving autonomy. Then application focus is defense, particularly defense, it is greater than 50% market share, and commercial energy sector fastest growing applications, and regional growth like North America leads, Asia Pacific is the fastest growing region. So these are the status globally, that Orca XL AUV, that is high endurance, extremely high endurance underwater vehicle. Then Lionfish, it is it's a small UAV for mine countermeasures. Then Snakehead, it is LD UAV, submarine launched large diameter UAV for intelligent preparation and clandestine OPS aid of the host vessel. Then rapid acquisition AUV, that is partnering with commercial vendors Anduril, Kongsberg to fast track new capabilities into service. And European initiatives, a lot of countries are working like UK, then France, seabed warfare strategy, developing the uncrewed combat unmanned underwater vehicle with naval group for defending critical subsea infrastructure. Germany, they are working on modified underwater mothership, that is ThyssenKrupp, modular UAV designed for long endurance multi-mission operations. Norway, already they are very famous. They have the Kongsberg, Hugin, and NIOT also, or MOE, Ministry of Earth Science also, they have projects on such kind of vehicle, that is Hugin 6000. So benchmark high endurance AUVs, that is superior endurance, widely deployed across NATO for deep water survey and defense. So what are the challenge in different technology trends, particularly it's a GPS denied environment, and UAV must navigate without satellite signals, leading to significant position drift over time. So this can be, the technology enablers might be SLAM algorithms, build real-time maps for self-localization, uncertainty aware AI enables vehicles to assess positional confidence and self-correct autonomously. So another challenge is the battery limitation. Standard lithium-ion batteries have insufficient energy density for long duration, so high power strategic missions. So that's why hybrid systems, it can play a major role to enable this technology domain, particularly fuel cell and battery to be integrated together so that we can have very high mission time. And another challenge is communication. So acoustic communication are the only viable underwater method, but they are low bandwidth, high latency, and acoustically detectable, limiting the stealth features. So that's why this constraint drives the need for higher autonomy, forcing UAVs to operate with extended independent decision making without real-time human input. So current in Indian scenario, CSIR NIO is working, they have developed Maya, and L&T, they have transferred the technology. CSIR CNR Durgapur, we have developed AUV for 150 meter depth of operation and for 500 meter depth of operation. Very recently, we have transferred the technology to Messrs Kollani Strategic System Limited, which is a part of Bharat Forge. And Guardian shipbuilders, they have developed the Nilaxi, a small AEV 2.1 meter long. Then DRDO, they are involved in high endurance autonomous underwater vehicle. So this is taking right step, and that is major lead is taken by NSTL Vizag. Then Indian Navy has also made a roadmap, and through that, a very high, extremely high endurance AUV is also taking shape through some Indian counterpart. Apart from that, lot of private partners, they are also coming into picture. As I said, the L&T versus Bharat Force, that is the Kollani Strategic System Limited, then Sagar Defense, and all other partners, they are also coming into picture, and they are playing a major role to make a Atmanirbhar Bharat. But what we are lagging for this autonomous underwater vehicle development is the indigenous components. So we need to focus on indigenous components also. So, so these are the capability gaps and path forward. So for XLAEV development, operational prototype ORCA in advanced testing and trials in other countries. But in India, we have just started manufacturing, and it will take 5 to 7 years. So I mean, we are almost 5 to 7 years gap is there to take up that kind of technology awareness. And particularly for AUV and small AUV deployment area, particularly widespread mature fleets like Remos, Hugin, hundreds number of deployed. So in this case, the prototype, particularly in trial stage, CNRI has developed AUV 150, and AUV 500, NIO has developed Maya, and this Nilaxi has been developed by Guardian shipbuilder. But these are sea trial and other things have happened, but commercialization is yet to take shape, though we have transferred the technology to that, to some very industrial partner, large industrial partner. So deployment gap, lack of large-scale production and operational experience, this is another major gap we are facing in Indian parlance.
We have
then endurance and propellant.
Another 5 minutes for the
High fuel battery system enabling month-long endurance. So here we can see that energy gap, advanced power sources remain to be developed. AI and autonomy, human on the loop control, swarming and dynamic real-time retasking. So here the dynamic decision making is a critical development hurdle. Industrial ecosystem, mature and competitive, defense and primes are agile commercial disruptors. So industrial base gap, competitive private sector needed to accelerate the innovation. So if you, so it's not working, please. Yeah, so these are the challenge. So inner space is difficult to conquer, dynamic medium, hydrostatic pressure, density and salinity variations, temperature variation, corrosion, and absorption in EM radiation. So solution is underwater vehicles. Some problem I am facing for this change. So these are the design requirement. Now I will come to, these are particularly in the underwater robotics at CSA or CNRI, we have developed AEV-150, and that is, the sea trial is done with active cooperation of NIOT Chennai from the Chennai coast. Then this is ROV-500, remotely operated vehicle. We have tested also at Chennai coast with NIOT. So both the project was sponsored by Ministry of Earth Science under supervision of NIOT Chennai. And we have also carried out AEV-500 developed and tested from the coast of Goa with the ship of NIO. That was a CSIR funding project under Ministry of Science and Technology. So these are the typical operation of autonomous underwater vehicle. This is a ship, this is a AEV, and they are in constant communication with the acoustic devices. And there are different sensors like navigation sensor, payload sensor, energy system, onboard intelligence, and there are of course obstacle avoidance sensor or obstacle avoidance sonar, and for mapping there are side scan sonar or multi-beam sonar. So this is the video of AEV-150 when it was tested at sound is not coming. No, it's not changing. The video, how to?
Sir, video can you play it from some?
Yes, you just play this. Go back. No, it's not the same screen. No. Some issues are there. Yes, this video, now it's working, but sound is not coming. Again it stopped. Yes, this operates, but sound is not there.
That's a sound is.
Yeah, this is the AEV-150 what we have tested long back around 2011. But based on that expertise, developed on this AEV-150, so we came across further development of autonomous underwater vehicle for 500 meter depth of operation, and it is having some problem is always there. So these are various modules of this AEV 150, and then these are various components like forward-looking sonar for obstacle avoidance, then different kind of lights and camera for environmental getting the environmental video, then acoustic modem and acoustic communication system for communication as well as sending the data. Then INS DVL altimeter depth sensor for navigational purpose, lithium-ion batteries, and then GPS antenna when surface operation will be there. Apart from that, it is having number of actuators to control various degree of freedom. This is tail thruster, to vertical thruster, and to horizontal thruster. So these are overall achievement for AEV 150. Slides. This is the camera view what we have got from the Idukki Lake that time. Slides. This is also some observation from the lake tile. Next. So these are AEV 500 assembly and integration at our shallow basin, which is around 50 meter long, 10 meter wide, and 5 meter depth. So these are overall glimpses of operation of AEV 500, that is the sea trial at Goa Post with the ship of NIO Goa, and monitoring using a GUI. Through that we used to have some emergency communication using the acoustic link as well as the monitoring of some of the important parameters. So this kind of AEV, it requires number of subsystems, particularly mechanical subsystem, power system design, navigation guidance control, that is a major area, and there are dynamics, then hydrodynamics, then control, mission planning, and all these things. So these are the different areas what CSR CMER is working: design and analysis of robotic system, power and energy system design, hydrodynamics, then communication framework, advanced controller, as well as navigation guidance and control. So this is stress analysis, hydrodynamics, then drag calculations, dynamic modeling, control surface and area calculations, then control of control framework of AEV, hydrodynamic derivative calculations, then simulated trajectory profiles, and then zigzag maneuver of AEV 150 that has been also tested through simulation as well as through experiments. So then what are the different sensors used in autonomous underwater vehicle, and for that we need to have a sensor fusion perspective, because different sensors are placed at different location of this long AEV. So we need to have proper mapping from body frame to global frame, and we need to integrate the sensor data, then communication methodology. So this is the typical navigation guidance and control framework. There is a trajectory tracker, and through there we are getting the set position. There are robust controller, then vehicle dynamics, and then required control forces are going to that thrusters, and then vehicle is moving, and it is measured by different sensors. And there are sensor fusion module, and also there are USBL transponder. From there we are getting the absolute position of the vehicle, and accordingly the fusion is taking place and it is going at the set position. In between, if there are any obstacle detected, then it is coming to the trajectory tracker. So these are the total expertise available at CMERI: the hydrodynamics, control surface design, kinematics and dynamics, then actuator calibration, then stress analysis, sensor calibration, modeling and fusion, then actuator calibration and robust control methodology. So currently we are working on deep ocean mission, homing and docking of an AEV, multi-sensor fusion for underwater robotic system, and underwater thruster for 1 kilowatt power rating and 1000 meter depth rating. The major issue is that though we are developing AEV, but lot of components are still imported, so we need to indigenize that component. So in that initiative we are taking, we have taken thruster to develop and to come back, and to utilize into the our different AEVs. So this is a typical scenario of AEV needs to be taken in the docking station, and So this is the ship, this is the docking station, it is connected by power and AUV after the mission. When battery level comes to a threshold, the AUV should be able to dock itself. Yeah, just one more. So this is the typical docking scenario, and I will show you one video. This is the docking system development as a proof of concept we are doing, and I will show. Yeah, so this is one video which the docking system we have developed and we have tested in the Maithon Dam. So which is a DVC dam. So we have developed a prototype AUV and a dock, and we have made AUV understand that in which quadrant, maybe first quadrant, second quadrant, fourth quadrant, or third or fourth, whatever might be your position, you are able to detect your door, so that this is your front door. So this is the docking system related exercise we have proven, and now we have some more work. So this is the obstacles what has been placed in the Maithon Dam, and this is the dynamic obstacle. We have used our ROV as a dynamic obstacle, and we have carried out some tether-led mission also, and then we are able to take the AUV into the docking station, wherever might be its position, whether it is first quadrant, second quadrant, third quadrant, fourth quadrant, anywhere. And it is able to come avoiding the obstacles inside the docking station. So this is the dock and this is the AUV, and you can see that AUV is able to dock itself inside that. So this is the obstacle avoidance strategy, how sonar stream of mission is used for obstacle detection. There is some sound, but that is not coming. I don't. So this is the sonar data. We are able to detect that AUV is coming inside the dock. So that is mounted on the docking station itself. So this is basically the graphical user interface, and real-time data we are also able to see from the surface that how that AUV is entering inside the dock. Okay, thank you for your patience. If you have any questions, I am ready to provide that, take up that question.
Thank you, Dr.
Thank you so
Nandi, for guiding us on these points of market trends, technology trends, what are future challenges, enablers, and also walking us through all the projects and products that you have done at CMERI. We have the session open for the question answers. If we have any from the audience, one or two quick questions, we can take it.
Yeah, any question? Otherwise,
XL UUV, what you have shown.
XL AUV.
XL large unmanned underwater vehicle.
Yeah.
How do you plan to give the long endurance for?
So XL AUV, what I have shown that it is the current trend that people are going to develop XL AUV for India, high endurance, to get the high endurance mission maybe more than 1 month or so. Like NSTL is developing high endurance autonomous underwater vehicle, and Indian Navy is also taking some steps to develop XL AUV. So as a design expert from CMERI, we have provided some design guidance for XL AUV development to Indian Navy. So that I can say.
So it is only a
but it's not possible for CMERI to develop XL AUV because we don't have that much of infrastructure, but jointly we can develop, definitely. Okay.
Thank you.
Any other quick question? Or we can have a set of questions during the lunch hour as well.
Okay. So currently, our main challenge is the homing docking system development. That proof of concept, we have got some success, and we will be taking it or scale up that, endeavor, and we are trying to take some bigger project in that domain also. Thank you so much. Thank you to the organizing committee for giving me the chance to talk in this, prestigious event on underwater robotics workshop. Though NIOT used to be our second home, I used to be here from 98 onwards. We have good collaboration with NIOT, and we are having several projects in that domain. So thank you so much.
Thank you, sir. So once again, now may I request Mr. Gopakumar, Deep Sea Mining Group, to present the memento to Professor Nandi.
Sir.
Please, sir. Now we'll move with second speaker. It's my great pleasure to introduce Dr. Vedachalam, Scientist G, and Group Director of Deep Sea Technology Group at National Institute of Ocean Technology, Chennai. His areas of specialization include subsea power system, ocean energy technologies, underwater robotics, and deep sea engineering systems. He has played a vital role in advancing India's deep ocean technology capabilities and as instrumental in the development of several indigenous underwater systems and marine robotic platforms. One of his notable contributions is in his leadership in the development of Matsya 6000, India's indigenous manned submersible under the deep ocean mission, a landmark in achievement in the nation's deep sea exploration efforts. Dr. Vedachalam has authored over 100 research publications, holds several patents in subsea and underwater technology. We are privileged to have Dr. Vedachalam with us today to share his expertise and insights on deep sea technologies and underwater engineering.
Yeah, very good morning, dignitaries, gentlemen, student community, academia, everybody here. A very good morning to all of you. So my talk is about the deep ocean human-occupied vehicles. So as you all know, as the NIOT director was mentioning, the MOE's objective is to carry out multidisciplinary work in various parts of the Earth system and to come out with meaningful information for the protection of the planet. You know, our work on space is progressing, but our work on the Earth system is progressing relatively less. So to accelerate this work, MOES carries out various projects and programs which is connected to various Earth systems. And out of this, hydrosphere, cryosphere and atmosphere, NIOT plays a major role, driven by, Prithvi program and now propelled by two additional programs, Deep Ocean Mission and the Mission MOSAM under the Government of India. We are working on various projects, including development of robotic vehicles for underwater exploration for minerals and hydrocarbons, energy desalination, sustainable fisheries, all these for non-living resources and living resources. And Mission MOSAM is mainly for ocean, coastal and polar health monitoring, early warning and weather and climate. So in a nutshell, NIOT leverages technologies for blue economy and weather monitoring. So objective is like that. So coming to this presentation, our presentation is focused on the deep water robotic vehicle developments. So why we want deep water vehicles? Okay, so we all know that submarines are used by the Indian Navy. They are mainly for surveillance and the depths are limited to 300 meters or so. As we go deeper, challenges are there. So why NIOT is interested in deep water vehicles is a blue economy is a perspective. As our chief guest was mentioning here, that exploring minerals is very important. So in that case, mapping of the sea is very important, ocean is very important. So we have a lot of resources spread across the oceans around India. Even though it is Indian Ocean, is a global ocean, and the United Nations have given a lot of area for us to carry out surveying and carrying out test mining. For this purpose, underwater vehicles are the key. So these are all the various areas where deep waters prevail, and there is a need for us to go and explore and see where these resources are and whether they are commercially producible. So in line with the objectives, since more than 2 decades, NIOT has been developed a gamut of underwater vehicles, and this is our ecosystem which is shown here. We started our journey with the development of a deep water ROV in 2010, and this has been utilized effectively, followed by polar ROV, which has been deployed in polar regions, which got a lot of climate related information. Then we jointly released the autonomous underwater vehicle, which was operated, and the major outcomes were there regarding this AUVs. One of the thing was, it was able to search and identify the lost AN-32 aircraft recently. And then presently we are developing a human submersible, Matsya 6000 as everybody is aware. In addition to this underwater vehicle, we are developing in-situ soil tester and deep water coring system, mainly for characterizing the seafloor properties and for ground truthing of gas hydrates in the Indian waters. And finally, we are also developing a system for integrated mining system, which is a crawler-based miner, which will collect the resources from the seabed. So now, having mastered this technologies, you can see here, this ROV, deep water ROV, polar ROV, shallow water and AEV and the autonomous scoring systems. Now we are transiting. All these technologies have been transferred to the industry effectively, and L&T and Bharat Electronics Limited are now making it commercial. So now we are hand-holding them, and parallelly we are now transiting towards human-occupied and autonomous segments actually. As mentioned in the morning, the human-occupied segments, starts with Matsya 6000, which is ongoing, and then it is going to be a biodiversity submersible, and finally our target is establishing a deep ocean observatory where humans could be shuttled there periodically for deep ocean research. And in the autonomous segment, we are working on Trinetra Shakti, homing and docking AEV for sustained presence at sea, and then deep water vehicle RE6000, and a swarm of AEVs for time-bound search. Time-bound search is very important because if some missing targets are there, we have to identify on time. And finally, we are planning to develop a lot of hybrids, high endurance and bio-inspired vehicles, for which we are having various collaborations with the DRDO labs, ISRO labs, and various private universities such as IITs, SRM, SSN, etc. So our aim is to design, develop and demonstrate, and then transfer to the industry effectively for societal applications. So now coming to this Matsya 6000, it is a small mobile underwater research vehicle which can go up to 6,000 meters. So basically it started 5-6 years back, and there was a lot of denial from the international community because of the transfer of technologies involved, and we were not given the technology or the wherewithal for making this submersible even now. And under the deep ocean mission, we were given a chance to develop this submersible in-house, and that period the principal scientific advisor was there. He convened a meeting and he brought all stakeholders together and all technology partners together, including ISRO, DRDO, etc. And now hand-holded by everybody, we are developing this Matsya 6000 under the Make in India. If you see the submersible, if you see the ship, basically submersible is a microscope actually in the vast ocean. It carries out a pinpoint survey, not like an AUV which can have a wide area survey. It carries out a pinpoint survey. So it is taken, the Matsya 6000 will be taken on board the ship to the location of interest, and it will be deployed there, and it will carry out the operation. Basically it is tetherless. You can see a lot of systems will be there on the ship for support, and Matsya 6000 will have a lot of subsystems to do this one. So this is the overview of Matsya 6000, and the specification of this is 6,000 meter water depth, and the human cabin will be of titanium alloy. It has 3 viewports and it can go at the speed of 3 knots. The endurance will be 12 hours and it will support 96 hours of emergency. The weight is around 28 ton and it is lithium polymer battery powered, and it has an acoustic telephone to carry out regular voice communication with the ship because there is no tether. So that is very important, and it is through the data modem also. Coming to this thing, NIOT already we have mastered unmanned systems, but then what is important, different in this manned system is that the human cabin, it has to withstand the crushing pressure of 600 bar. So we have not done that so far. So that material is very important and the fabrication process is very critical. Then the viewport design, even though it is a metal shell, we should have some openings to see. So that is to be acrylic, and that technology is also new for us. And then the hull penetrators, these are all weak points in the human cabin, that is to be addressed, and then life support systems for 96 hours. So that is critical, and then in case a submersible sits on the seafloor, how to rescue it? That is an important question. So emergency. So all these things are critical technologies that we are addressing. So this is a view of Matsya 6000 showing various subsystems here. The human cabin is in the front, carries yellow color one, and then the blue color is ballast management system, which will enable the submersible to go up and down without the expending energy, and we have thrusters to enable the movement in multiple degrees of freedom. And the entire thing is housed on the exostructure, and we have a lot of communication and things all around. And in the front you can see the robotic arms which can be used for carrying out intervention with the seafloor objects and collect samples. The length you can see here, the width is you see, and the air weight is around 26 ton, but in underwater it is almost neutrally buoyant for enabling efficient propulsion. So we are not doing this alone. We are hand-holded actually, as I told you that for several years we have been arm-twisted by Western countries in America, and now we are now developing ourselves. So our handholders or our collaborators are ISRO, VSSC, LPSC, ORAC, these things, and Indian Navy. Then various labs of DRDO are supporting us. CMRI labs are supporting us, and then MIT, we have organizations supporting, and we have 20 active Indian universities. Even though we have given 60 universities various collaborative projects, 20 are active and 4 or 5 are super active. So I would like to mention them in between during my presentation. And we have a collaboration with the Krilo State Research Center, KSRC, for qualifying our human cabin up to 900 bar. And we have taken this, we have given a contract to DNV Germany to validate our design, validate the submersible design. So the Matsya, this is the Matsya development ecosystem you can see here. So the balls represent the subsystem of Matsya, and the inside this one shows the industries involved. You can see the human cabin where, you know, so many industries are involved, VSS, ISRO, LPSC, L&T, so many companies are involved here. And then you can see the countries which are involved in the supply, you know, right from, you know, Western countries are mainly, you know, they are supporting us for this thing, and there are totally 50 major organization. I am not telling about the small vendors and all. Small vendors, if you put together, it will be 450 organizations are involved, but major subsystems, if you take 50, of which 31 is foreign and 19 is Indian, and import is facilitated by almost 10 companies actually. So now you might ask a question that what's new with Matsya, what as our director mentioned is a 4th generation submersible. So in what way it makes it 4th generation, even though America made this in 1964? No, America made this in 1964 because we know that, you know, necessity is a mother of invention. Because America wanted to, you know, carry out failure investigation on the reasons behind the, you know, sunken Titanic actually. Even though ROVs are there, they wanted to put man there to physically see what's happening. So with that purpose only, America developed this, you know, Alvin in 1964 actually. Then after that, once it was developed and the purpose was solved, this submersible went into the classified category by US, American US. And after that, there is no information about the public domain. Then after that, you know, after you see some 15 years after, the 2nd generation submersibles were there for various developed nations, Western countries. And later, the 3rd generation submersibles came actually. They were mainly focused on the hurdle depths. Hurdle depths means more than 6,000 meters, in which the Mariana Trench, etc., where the depth is around 11 kilometers. So the host of submersibles were proven at the ultra deep waters of 11 kilometers. And now we claim that we are the 4th generation because we have some unique technologies here which have distinct features which ensure safety and performance of Matsya 6000. Right? We have to be very safe because Western countries, you know, tell their success stories, but nobody tells their failure stories. Okay, so we should not burn our fingers, and therefore we are extra cautious in this development. So you can see that emergency drop aid, subsurface hovering, electron beam welded human cabin, you know, emergency rescue system, batteries, all redundant controls, this crew health monitoring system, all these things are digital twin, you know, Chaitanya, all these things make Matsya as a very unique thing compared to the global submersibles. So now, okay, so here submarine people are here. So there is a question that what is the difference between the submarine and a deep water submarine. Starting with this external environment, you know, outside environment, outside a submarine is high pressure, low temperature, low visibility and low communication bandwidth because of acoustics. This poses a challenge as we go deeper and deeper. So that is the external environment challenge. Then we see the internal environment, though it is not a big submarine where lavishly space is available for habitation. So it's only a 2.1 diameter small cabin, right? During the emergency period, we cannot even stretch the thing, and 50% is occupied by equipment. So little space. Life support system is only for 108 hours. The critical thing is that in case if you fail to rescue the people, you know, within 108 hours, the thing is that one starts attacking the other for the use of oxygen. So that is very critical. And then onboard energy is limited. And finally, human psychology. You know, why we are taking more time, even though people are asking that this project is sanctioned 3 years back, why this Matsya has not come into, you know, realization or, you know, demonstration, so now. We are driving the human psychology. Human psychology is going to 6,000 meter water. You know, it is a very challenge. Even though Westerners has done, they did not do it immediately. And the time taken is not mentioned in the literature also. The problem is untethered. It is untethered, there is no cable. Then time to surface is 4 hours, right? Normal submarine takes 3 minutes to surface, whereas this takes 4 hours. Then fear of fault aggravation. If a switch creates a spark, he will be afraid of using the second spark. For example, imagine if you receive a shock in your house switch, you will be afraid to switch the next switch for a few minutes. So fault aggravation. Then finally, if he is stranded to the sea floor, who is going to rescue? What will be the sea state, right? So many things are questioned here. That's why we need a that's why we need systems to be reliable, life support system, mission critical system, and pilot has to be physically, physiologically and cognitively, fit for this operation. So these are the things. So as usual, like other submarines and ship, we underwent through a very detailed system engineering, multiple spirals of system engineering, and mainly to meet this center, depth, crew, and the weight targets and the power targets, and ultimately the safety integrity level 3, which speaks about the safety of the crew. Safety of the crew means in case in a system, if 3 people are there, life is endangered, the safety integrity level of the system as per international standard has to be in the 3rd level. So this is our target, and our entire design spins onto this target. So this is the way how we did this, safety centered engineering. So the first set is SIL1, where, standard all DNV regulations are followed to achieve the system reliability. Then introducing the service drop weight redundancy comes to SIL2, and then we introduce emergency drop weight and the jettisoning system, we achieve SIL3. Even though we achieve SIL3 and we say it is adequate, for example, if we see an aircraft is highly mature, then why they have parachutes? So for this purpose, we have an emergency rescue system to rescue the system in case of emergencies, and we have a digital twin support. Our development follows the philosophy of ALARP for mission critical systems and ALARA for life critical systems. You mean that for life critical systems, we don't see the cost, time and effort involved. We have to see to that the maximum level of reliability is achieved, and there is no trade-off, because human life has no trade-off. That's the reason we go by the principles of ALARA. So then coming to the, human cabin is one of the most critical systems in the manned submersible, where people sit and all. Thanks to VSSC, ISRO, and their collaborators of ISRO organizations. So they have promised us to deliver a human cabin by next year. The technology is through multi-ring welding, and the V-ports you can see here, it is presently under fabrication. We have funded them to develop electron beam welding facility. And once it is welded, by next year it is coming, that will enable us to carry out deep ocean mission, and finally it will be hyperbaric tested in Russia. Then the second human rated thing is that we have axisymmetric architecture for the submarine. We have total number of 160 electrical and electronic harnesses running through the submarine, that will enable us to have redundancy as well as damage tolerance. All the components are qualified at 720 bar and type tested at 1200 bar, double the pressure. So that will give a highest level of confidence for the man who is going to travel in the submarine. Then human cabin. Human cabin is very important, you see, because the emergency time, submarine has to sit on the seafloor for 96 hours unless he is rescued. So at the time power will be rationed, and it will be switch off all the equipments, computers, everything will be switched off. And after 96 hours, when he has to switch on, when it switch on, it has to come back to normal. So we qualify the system for a black startup after some time, and this is extensively qualified human cabin. So now what happens is that everything is done, emergency thing is done, so now we have a drop weight system which can be operated from the ship actually. This is a very speciality of Matsya 6 compared to other submersibles. Normal submersible has self-contained everything. The emergency drop weight will be on the submersible, will be operated by the pilot during an emergency. But here, in case if the crew becomes incapacitated, either physically or physiologically or cognitively, and if you are not able to operate the emergency drop weight, then the pilot from the mission control center in the ship can issue a command to drop the weights, and the submersible can. That's why we given the name Rakshan. Rakshan means a person who is protecting from this thing. So it's called Rakshan. Then emergency jettisonable system. As you know, when the submersible has front this robotic arms to carry out intervention, right? This is similar to a crab. What happens in a crab when the two arms are doing some operation, and if one hand's got stuck up inside a mud or some rock, the other hand will amputate the other arm and it will escape actually. It's called amputation in crab. So likewise what we do is that using frangi bolt we amputate these systems and we relieve Matsya from the entanglement actually. So we have a very clear, very defined mission about protocol where we have this booklet pre-written in a very nice way that the pilot will know when to take a decision to surface, normal surface, accelerated surface, and when to rapidly surface. This will be written here. Once he crosses the E zone, then he will do whatever thing he wanted and he can surface. But he will not come out, but the submersible will be forced to come as quickly as possible. This is called the mission about protocol. So then, as I was mentioning about the digital twin, actually digital twin is made in association with SRM University Chennai under the Deep Ocean Mission Collaborative Project. So the thing is that, when humans becomes incapacitated cognitively, he cannot take any decision on the niche use of the resources, pragmatic view of the resources like battery, oxygen, and the operation of the critical systems and where to hover and all. This digital twin, based on the scenarios, it will support the crew and it will give advanced decision to the crew, what to do, when to do, how to do, etc. So these are all the real-time inputs going to that, and that's the thing. At any point of time, a decision is taken, it will give a suggestion on what to do. So basically, it's a decision support system. Its name is called Chaitanya, and it is a multiple factors are involved here actually. So the data will be coming from the Matsya to the top, and Chaitanya will be running on board to take a decision. So now coming to the human reliability, people have to be physically resilient, physiologically adaptable to stress and cognitive. So we have followed this approach, because in other systems like AEV and other things, it's only the hardware and software reliability. Here we have human reliability to be built in. So this is how we went through. We developed the human reliability through cabin ergonomics, task allocation based on cognitive measurement, EOP, MAP, simulated training and not-ill training. And finally, if everything goes off, the human is supported by the cognitive twin actually. So this is called the famous Ramusan SRK principle. So now, we have two interesting systems called Manu and Dhanvantari in addition to Chaitanya. The Manu is a system in which human factors or human factor engineering is done. It's a physical twin where we capture, behavioral informatics, and we carry out, ergonomics of inside using this one, and cognitive load distribution. Basically, this will be used for screening a pilot for an operation. Basically, it will help us to identify the crew baselines for the mission actually. Then with the help of, this DRDO double, we have made a, but they have given a BioVest. Using that BioVest, we have made a AI-based tool, which is called Dhanvantari. The thing is that even though health parameters are transmitted regularly to the ship, it takes a lot of bandwidth actually. This Dhanvantari will be on board. It's like a resident doctor who will measure the health parameters and all, and it will flag the ship only during anomalies. Until then, it will say okay and all. Some 6 or 7 parameters are monitored, and then the anomaly is flagged actually. So this is under development and under the training phase actually. Then to impart confidence in this thing, our scientists who are identified as a crew, as a pilots, went and dived in Nautil, France to get acquaintance on the mission planning and operations. And this is the tests of the wet test carried out in the port actually. Here the life support systems are qualified, the watertight integrity is qualified. This was done during January, February 2015, last year. Hydrostatic stability was understood better. Then life support system was done, and maneuvering was done, which is a baby step in this process. And then now presently what are we doing is that we are qualifying the emergency systems, and we are trying to qualify now we have conducted phase 1 of the emergency rescue system, in which this system will pop up to the surface and it can be used for retrieving the standard submersible. This name is called Abad Bandhu. So 500 meter we have qualified, 6,000 meter we are yet to qualify. And finally, the people's question is that when are you going to go to 6,000 meters? That's the only question. So as I told you, confidence building is very, very important, because more than engineering reliability, it's going to be the human psychology. So we are planning to do this in stages. 2025 we conducted this phase 1 as wet test for these different objectives, and by August we are planning to go just the subsurface, 20 meters, using the Indian Navy ship and carrying out maneuvering underwater. Upon getting confidence on the emergency response and all these things, which is phase 2, in phase 3, by the end of 2026, we are going to have an unmanned dive up to 500 meters, and then a manned dive, which will give an idea on the depth integrity up to 500 meters, navigation and operation acquaintance. Then once we receive the ISRO-made Spear, it will be retrofitted on the existing system, and we will carry out again a depth integrity at 3,000 meters, and navigation preparedness will be understood in the phase 4. And then in the phase 5, we take the vehicle up to 5,500 meters, carry out the design depth qualification, and carry out a mission. And from that point of onwards, Matsya will be available for biological, geological, chemical and oceanographic community for scientific applications. I thank everyone for the organizers and NIOT management for giving an opportunity to describe about Matsya 6000 progress. Thank you.
Thank you, Dr. Vedachalam, for this great presentation. We had walkthrough of the manned-unmanned vehicle ecosystem, the entire Matsya system, subsystem challenges of manned missions, why life and mission critical systems are important, rescue systems are important, and aspect of moving from mission preparedness to the mission execution in this Matsya system. Thank you for this talk. Let us have a session open for the question answers, if I may. We have.
Thank you, sir, for a wonderful presentation. First of all the best for the Matsya. So we are anxiously awaiting for a 2028 launch. Sir said because we should not burn the finger, but we should not also fear of the failure. See the example of ISRO, where PSLV was their trusted rocket, but recently 2 successive PSLVs failed. So that is not a problem. Then, sir, in your opinion, there are several denied technologies you mentioned. So which will be the most critical one that may affect the schedule of 2028 launch?
Okay, so thank you very much, sir, actually, for the encouragement. And with reference to this ISRO rockets, etc., Gaganyaan is going to be the manned mission and all other missions are unmanned. So the thing is that their failures are tolerated, even though, but people say that government doesn't tolerate the failure, but government cannot tolerate a failure with humans. That will completely paralyze the program. And therefore, even if you are getting a name that we are late, but we should not get, damage actually, which cause damages to the organization as well as ministry, and the world is around watching around. So that's why we are, taking up a very cautious step on qualifying this equipment for pressure. Because, human cabin, if you take, it is surrounded by a pressure of 600 bar. So any leakage, the jet created is equivalent to a pressure of a water jet cutting machine. And it will cut through humans, machines, etc., which is inside. So that's why we are planning to have a very cautious way of doing multiple ways actually. So much more than ISRO also to qualify the system. Because as this is being a manned mission, we cannot operate it in the unmanned mode in the beginning because controls cannot be taken out because the configuration is manned. So because somebody cannot make a car and operate as a remote car, entire configuration will change. So in that case, as man is there, we are assuming that man will start the mission and we have to be cautious. So that is one thing. And second thing, you are asking, major showstopper in this thing. So we are categorizing the systems into 2 types actually. One is called the mission critical system, another life critical system. Mission critical system is all cleared actually. We have done everything and it is ready last year itself. Only the life critical systems are some dropping the weights reliably. Because when we are going closer to the sea floor, if you are not able to drop the weight, you are going to bang on the sea floor. Likewise, in case if something is to be flooded and you are not able to drop the weight, you are going to gravitate on the sea floor. At that time, rescue is very, very important. Okay, whole world is watching. It will be a big problem. Even if somebody falls in the well, the whole media will come there. If something happens in the ocean, then imagine it will be a very stressful scenario for the entire country. And therefore, we are trying to put all efforts to see that system is fully compliant before any mission. That really takes a lot of time. And in the 6,000 meter configuration, the thing is that the human cabin is a critical element because we don't want to put any pressure on ISRO. Because any pressure put on ISRO should not compromise quality. ISRO has its own way of doing.
You are making multiple units, right? Because hyperbaric test, that same unit won't be used again for actual mission, right?
Yes, sir. Actually, it's ISRO. What we are planning is that the series of companies are involved. Right from Midani is going to who has supplied this, titanium ingots, and then VSS is design, and L&T has machined that, fabricated that, and LPSC has electron beam welding that. And once this is done, the entire system will be taken to Russia, to KSRC, to qualify at 900 bar, which is 1.5 times the pressure. And that will be certified by and it will be witnessed by DNV and certified it as mandated. The DNV representative or the surveyor will travel with us in the submersible up to 6,000 meter water. And therefore he has the onus on the safety also. So he is not certifying and going to be in AC room. So he is going to be a part of the mission. And
so the same tested vehicle will be used?
Yes, which is qualified in hyperbaric chamber in Russia will be used here. Multiple cycles will be done.
Okay, just one more small question related to the first answer. See, because you are telling that there is this man and human psychology is one of the most important factor. So the pilot and crew are selected from NIOT. They are very much competent, and I fully agree. But when ISRO selects, they go for say pilots or Air Force this thing. So similarly in Navy there are experts who are in diving up to submarine 300 meters or something like that. So why can't select from that also, include, just I'm asking.
Yeah, correct, sir. We follow the same philosophy, or we followed the same philosophy 1.5 years back. So understanding the psychology and the safety of the operation, and so we selected one retired pilot from Indian Navy. He's JP Singh. He is among the here. So he was a commissioning pilot of deep submergence rescue vehicle. Deep submergence rescue vehicle is in Visakhapatnam actually. So there is an organization called ISMERLO world along. If any submarine encounters an emergency, based on the SOS received, so they will coordinate the rescue operations, in which this DSRV goes and sits on the hatch of the stranded or distressed submarine, and it will rescue the crew and it will come back in multiple sorties. So that commissioning pilot we have recruited as an NIOT scientist here. In addition to that, another pilot is there from NIOT who is a developer of the submersible. So like the test pilot and the aircraft actual pilot. So he is also another pilot, and he is going to be trained at an international facility in UK, where the same Navy pilot undergone already. So he will also join the same thing. And we are also looking for more pilots in future, for which our management approval is awaited. Yes.
Thank you, sir. I forgot to introduce. I am Rajesh Kar from CDAC. Handing over to.
Good afternoon, sir. I am Kamrul Vikrant from Indian Navy.
Yes.
I'll be just putting a very logical question, sir.
Please.
I mean, as we know, I'm an oceanographer and meteorologist by profession, and educationist also in Navy, and have a 30 years of experience serving ashore, afloat, operational, administration, training. So my question is very simple, sir, logic. I mean, I have been associated with weather forecasting and oceanographic state forecasting as well. Now, when I'm a meteorologist, I see the weather happening. Whatever I issue a forecast, I can see what is happening. Okay, it is cloudy, it's going to rain, it's windy, it's warm, it's cold. But when I issue an ocean state forecast, I'm depending only on the data which I have, that too very sparse data, which I have collected through so many data platforms, where I cannot myself visualize, neither there is anyone to visualize in the depth of the ocean. Like in weather, we see that what's happening. There you cannot have any validation as far as human beings are concerned. As aptly pointed out by our chief guest, Vice Admiral Das Gupta sir also, that we need to explore the ocean depth to a very greater extent. And my question is this Matsya 6,000, how many Matsya we are going to have in future? Because one Matsya, I think, will not be able to solve the problem or collect the data of the so-called South Indian Ocean, some 1,500 nautical miles from the Indian subcontinent. I think one Matsya will not suffice.
Yeah.
That is one.
Yes.
So, plus my very logical question that who are going to validate this oceanic data. And my third submission is that I have interacted with US Navy, French Navy, UK Navy also. There is a collaboration of the scientists with the forces, defense forces. They are basically deployed and so-called like honorary commissioned into the services so that they work in tandem with the forces, knowing the cause and whatever is required by the services. So that collaboration part also, I don't know how far we have been able to give a thought to it. And lastly, since serving at sea and serving underwater is not that easy. It requires a lot of courage, and you have to be medically fit to serve at those depths and willing. The most thing is that you should be willing to go at sea or underwater. So all these things will, I think, if we are positively addressing this Matsya 6000 mission, I think it will go a long way in serving the purpose what our Prime Minister's vision is all about. That's all, sir. My submission, I mean, just a submission. That's
Please,
all,
sir.
sir. Thank you.
Answering your...
Sorry for interrupting in between. Thanks for this submissions, and I guess it comes from a very good experience from the naval side. You can have a quick response to that. And
Yeah, of course. I am watching the time.
In absence of time.
So I am watching the time. So first question to answer is, sir, actually this Matsya is not for, very large area surveys. So it's only for a pinpoint investigation. I was already telling you it's a microscope in the ocean where it has a very special limitation. Battery is basically battery driven. It has to be taken to a point of investigation and then it has to be lowered and it will have to come back in 4 hours. So it cannot carry out a large, oceanographic survey. For oceanographic survey, we have autonomous underwater vehicle. We have in our lab, Sir Eugene from Norway, and we are trying to develop one thing also. So that will have an endurance of 72 hours actually. So notwithstanding 72 hours, we are also thinking of making 72 plus hours by augmenting that AAV or a new AAV with the fuel cells which can run much more, probably a week or more. But even a week is very less for oceanographic purposes. And we are developing Trinetra Shakti, I told already, that will be at sea, always, with an underwater charging station like mid-air fueling facility, mid-water charging facility. It will extend the thing, need not have to recover that one. So that will collect a lot of information in very sensitive areas of, coral reefs, and are ecologically sensitive as well as, military sensitive, whatever it is. So it can be based on the application, it can be, vision loads can be there. So second thing is that with reference to the, psychological fitness of the people, so already we have a pilot who is psychologically fit and another colleague of me, Mr. R. Ramesh, who has been trained to be psychologically fit, and we are now very closely working with the DIPR, that is the Defense Institute of Psychological Research. So we are directed through Dr. UK Singh actually. So he is helping us to find out a baseline, cognitive baseline to identify the crew requirements. So that crew will be only identified, okay? Because even now, for Gaganyaan, now after identifying this, people from the Air Force, now they are trying to recruit people from the common pool also. Because cognitively fit people may be available in the common pool also. Even a normal person can go into that. So with this purpose, we are developing the system called SPCAT. Its name is called MANU, Submersible Pilot Crew Assessment System, where it will identify a crew fit for the Matsya mission. Not the third person, only the pilot and the co-pilot. Anyway, third will be the scientific observer. The third question, how to integrate, defense systems with our civilian thing. So that we will take your support, sir. Actually, our director told that as NMSC is here. So we saw in the net that his approach is all in one government, something like all the, sorry, I forgot that term actually. So with this, I think, all in one approach can be taken actually, because civilian services can be used in the military and military knowledge can be used for the civilian benefit actually.
Thank you,
So
sir.
I think,
Thank you for that answer.
Thank you, sir. Now I request Dr. Sarang to present a memento to Dr. Vedachalam.
We have our next speaker, It's a privilege to introduce Captain Vikas Gautam, officer in charge of the Submarine Rescue Unit, East Section of the Indian Navy. Commissioned into the Indian Navy in 1998, Captain Gautam brings over 27 years of distinguished service in the submarine arm with extensive expertise in both conventional and nuclear submarine operations. Throughout his career, he has been associated with several strategic submarine programs and has worked closely with a premier organization like NSTL, contributing to the advancements of India's underwater capabilities. As the officer in charge of the Submarine Rescue Unit, he has played a key role in enhancing the modernization, operational readiness and mission preparedness of India's submarine rescue infrastructure. Among his notable achievements is the maiden integration of the deep submergence rescue system on board INS Nistar, a significant milestone in strengthening India's submarine rescue capabilities. Captain Gautam has also led India's participation in Exercise Pacific Reach 2025, the premier international submarine rescue exercise, and successfully conducted mating operations with 3 international submarines in the South China Sea, demonstrating the effectiveness and interoperability of India's rescue system on the global stage. His expertise spans deep sea submarine rescue operation, underwater rescue system, strategic naval operations, and advanced technology integration. Through his leadership and dedication, he has significantly contributed to strengthening India's position as a technologically advanced and self-reliant force in submarine rescue operations. We are honored to have Captain Vikas Gautam with us today to share his valuable experience and insights. Please join me in welcoming Captain Vikas Gautam for his presentation. Over to you.
Permission to continue, sir. Good morning to all the distinguished guests. On behalf of Indian Navy's Submarine Rescue Unit East, it is my privilege to be here today at the National Institute of Ocean Technology, Chennai. I am Captain Vikas Gautam, Officer in Charge, Submarine Rescue Unit East. We often say that designing an underwater vehicle is an engineering challenge, but launching and recovery it safely at sea is an operational challenge. Before moving on to today's presentation and topic, let me first set the context by bringing out what we are and what we at SRU do. Music, sound is not there. Just bear with me, perhaps even the audio system has got mesmerized. Beneath the calmness of the ocean lies one of the most unforgiving operational environments known to man. A world where pressure can crush steel, weather can overpower technology, and a single mistake can turn an operation into an emergency within seconds. Yet, every day, underwater vehicles are launched into this hostile domain to execute missions of immense strategic importance. Every launch is a calculated risk. Every recovery an orchestrated evolution, and every emergency a true test of preparedness, leadership, and human endurance. Having had the privilege of leading Indian Navy's Submarine Rescue Unit East through numerous challenging operations at sea, I can say with certainty, launch, recovery,
and emergency operations are not just engineering evolutions. They are the ultimate test of technology, teamwork, leadership, and nerve. The DSRV system operated by Indian Navy is not merely a piece of equipment. It is a critical lifeline for submarines in distress. Designed to operate in the most demanding maritime environments, it provides advanced search capabilities that enable the rapid and accurate localization of a distressed submarine. Beyond search, the system is equipped to undertake complex salvage operations, allowing recovery of vital assets. Most importantly, its real-time rescue readiness ensures that we can evacuate personnel from a disabled submarine safely and expeditiously. We are the Submarine Rescue Unit East, the Indian Navy's specialized unit responsible for maintaining and operating India's submarine rescue capability, standing ready 24/7 to save lives beneath the sea. Now, having hopefully caught your attention, let us turn our focus to the main topic of today's presentation and examine the operation philosophy, procedures, and decision-making processes involved in the launch, recovery, emergency operations of underwater vehicles. I'll begin by bringing to fore a little introduction to Indian Navy's state-of-art DSRV capability. The scope of the presentation is as flashed. As shown on the slide, 4 major underwater accidents, including one of the deep-sea submersible, Titan, occurred since the year 2000. Each of these incidents highlighted the critical importance of having a reliable and rapidly deployable submarine rescue capability to ensure timely assistance during emergencies. Moving to the Indian Navy DSRV system. The Indian Navy maintains a robust and redundant submarine rescue infrastructure with one system each of the west and east coast of India to ensure seamless operational coverage. Additionally, we have a dive support vessel with a rescue bell in south. The Indian Navy acquired 2 deep submergence rescue vehicle systems with full air transportability, the first in 2018 and the second in 2019. The Indian Navy DSRV system comprises of 5 key modules. The side scan sonar, the remotely operated vehicle, the submarine rescue vehicle, or Tiger 10 as we call it, deck decompression chambers, and the launch and recovery system. In the demobilized state, the entire DSRV system is spread across the hangar in the DSRV complex. The DSRV hangar is one of the largest DSRV storage facilities in the world, spread over an area of approximately 16,000 square meters. This hangar arrangement is configured to facilitate streamlined mobilization and demobilization with provisions for trailers to roll in and roll out of the hangar. Mobilization is the process of configuring the entire DSRV system on board a mothership in its designated operational layout. Once fitted, the deck layout of a mobilized DSRV system on board mothership looks like as shown on the slide. Having set the context and provided a brief overview of DSRV system, I will now move on to the core subject of today's presentation, launch and recovery operations. Before examining the launch sequence, it is important to understand the underwater vehicles are generally deployed using 2 distinct methods, static launch and dynamic launch. The choice between these 2 methods depends primarily on the degree of control required immediately after entering the water. The first method is known as a static launch. In this method, the vessel proceeds to the designated launch position, and once the required heading and environmental conditions are achieved, the ship is brought to a complete stop. The submarine rescue vehicle is then lowered into the water with the ship maintaining 0 speed through the water. The second method is known as a dynamic launch. In this method, the vessel maintains slow ahead speed, typically between 0.5 to 2 knots. During the launch, the submarine rescue vehicle is lowered into the water and released while the ship continues to make way. This provides positive water flow over the vehicle's control surfaces, allowing the pilot to establish immediate control and safety separate from the mothership. Having looked at the various methods of launching the DSRV, let us now move on to the launch organization. Coordinated team structure that ensures every launch and recovery is carried out safely, efficiently, and with absolute precision. The officer in charge serves as the operation manager, exercising overall command and real-time control of the launch, dive, and recovery, while continuously coordinating with the DSRV pilots and the ship's bridge. The Chief Operations Officer acts as the deck manager, directing every activity on the Lars deck and ensuring the safe and precise execution of launch and recovery operation. The Master Rigger, or also the Naval Constructor Officer, functions as an independent safety officer, maintaining focus on the safety of personnel, equipment, and adherence to all safety procedures. The DSRV crew, comprising of Pilot 1, Pilot 2, and a rescue chamber operator, is responsible for diving, maneuvering, and conducting all rescue operations underwater. With the launch organization in place, the next step is to understand the go, no-go criteria, the set of operational and environment limits that determine whether conditions are safe to launch, dive, and recovery. These criteria ensure that every operation is undertaken only when the ship, the rescue system, and the surrounding environment are all within clearly defined safety margins. These no-go criteria are grouped into 3 broad categories. First, the rescue system criteria, which defines the operational limits for the DSRV during the launch, dive, and recovery. Second, the intervention system criteria, covering the operational limits for the ROV and side scan sonar during search and intervention tasks. Finally, the generator criteria, which ensures that electrical power systems remain within the acceptable limits. With the criteria clearly defined, the final step is the evaluation of launch conditions, where actual weather, sea state, currents, ship motion, and equipment status are assessed against these limits to arrive at the most important decision of all, go or no go. The direction of the wind, combined with the prevailing ocean currents, plays a critical role in determining the ship's optimum heading and maintaining the precise position required for the safe launch and recovery of the DSRV. In addition to the wind direction and ocean currents, there are 14 key factors that are considered before commencing a launch and recovery operation. These factors help us to determine the most suitable ship heading, speed, and overall vessel configuration to ensure the evolution is conducted safely and efficiently. To assign the most suitable vessel configuration and dynamic positioning settings, dedicated DP trials are conducted. These DP trials are conducted prior to the commencement of the DSRV operations. This image illustrates a dynamic positioning trial where different ship headings and thruster configurations are tested against wind and ocean currents to determine the optimum ship's heading, speed, and control parameters to ensure the evolution is carried out safely. With all operational and environmental criteria evaluated and confirmed to be within safety limits, the decision is made to proceed. We now move on to launch sequence, the carefully coordinated series of actions that brings the DSRV from the deck to the water and prepares it for its mission below the surface. This animation shows a typical dynamic launch run. The mothership first comes on the selected launch course, keeping the disabled submarine abeam of her. At approximately 500 meters, the Lars is moved outboard and the SRV is prepared for launch. At around 200 meters, the SRV is lowered into the water, while the ship continues to make slow ahead speed. At the launch position, the SRV is in the water, connected to the bullet and under tow from the mothership. The bullet is first disengaged and the SRV propels ahead to a safe distance from the ship. Once clear of the mothership, the tow line is released, at which point the SRV is free to maneuver independently. The SRV then alters course to take station on the port beam of the mothership before commencing its descent. Upon reaching the dive position, SRV dives and makes approach towards the DISUB to undertake a rescue operation. Meanwhile, the mothership maneuvers to maintain safe operation and supports underwater communication and tracking. Having looked at the launch sequence, I'll now move on to the recovery of the submarine rescue vehicle, which is often considered the most and even more demanding part of the entire evolution, as it requires precise coordination between the vehicle, the launch and the recovery system, and the mothership under continuously changing sea conditions. The recovery of the SRV can be broadly divided into 3 steps. First, the mothership adjusts its heading and speed to place the SRV in the most favorable position for recovery. Second, the recovery team transfers the recovery tow to the SRV and the divers secure it to the vehicle. Using this tow, the SRV is gradually brought to a position close astern of the mothership. Finally, once the SRV is in the designated recovery position, the lifting bullet is lowered and connected to the vehicle, after which the SRV is hoisted on board using the launch and recovery system. As the National Institute of Ocean Technology advances the Matsya 6000 program, the extensive operational expertise developed by the Indian Navy in the launch, recovery and emergency handling of manned underwater vehicles presents a unique opportunity for collaboration. This proven experience can serve as a vital bridge between scientific innovation and operational deployment, offering valuable insights that will enhance the safety, reliability and mission readiness of India's deep ocean exploration initiatives. Discussions are presently underway to explore the possibility of launching and recovering Matsya 6000 using the Indian Navy's proven launch and recovery system. By combining the Navy's extensive operational experience in handling manned underwater vehicles with National Institute of Ocean Technology's scientific expertise, this collaboration has the potential to significantly enhance the safety, reliability and operational readiness of India's first indigenous manned deep ocean submersible. One of the most critical factors contributing to a successful launch, conduct of underwater operations and safe recovery of manned underwater vehicle is availability of a reliable two-way communication link between the vehicle and the mothership. This communication capability is also one of the key parameters considered during the go, no-go assessment. To ensure such interoperability for future operations, UWT trials were conducted between the Indian Navy's DSRV UWT system and the UWT suite that will be used on board Matsya 6000. I would like to play a short video showing glimpses of the UWT trials.
How is the crew health?
MCC, this is the Matsya crew health is healthy and fine. Gases are in specifications, depth 101 meter, atmospheric pressure 10 ops normal. Over and out.
Thank you, sir. Thank you.
Roger, ma'am, standing by. Romeo. Congratulations, JP, to you and the entire NEOT team for a successful trials and successful integration of NEOT set with SRU East and NISTAR. Revert back to normal. Change the.
The successful completion of the underwater telephony trials has established interoperability between the Indian Navy's UWT system and the UWT suite planned for Matsya 6000, paving the way for a future launch and recovery using the Indian Navy's proven launch and recovery system. Having explored the launch and recovery aspects, it is equally important to understand how the system responds to unforeseen situations beneath the surface. We now move on to the underwater emergencies and the procedures designed to ensure the safe recovery of both the vehicle and its crew. The list on the screen indicates a wide range of emergencies that can arise during the underwater operations, ranging from communication failures and tracking loss to propulsion defects and emergency surfacing situations. In cases where emergency surfacing is required for an underwater vehicle, several independent methods are available to bring the vehicle safely back to surface. The SRV is equipped with two detachable battery pods, one on the starboard side and the other on the port side. In situations, in addition to the battery pods, the SRV is equipped with a dedicated drop weight located on the underside of the vehicle. This drop weight can also be released using the emergency hydraulic system. Regardless of the nature of the casualty, our responses to any emergency is governed by predefined emergency operating procedures.
Sir, last few minutes.
Yes, ma'am. I think perhaps the audience is equally committed to what I'm speaking. So I'll just take 2 minutes more and finish it off fast. Thank you. So regardless of the nature of the casualty, our response to any emergency is governed by the predefined emergency operating procedures. Depending on the severity and urgency of the launch and the situation, the event is classified as X-ray, Yankee, and all stop, with each category triggering a specific chain of reactions and actions along with the reporting procedures. X-ray represents the highest category of underwater emergency. Yankee is declared when an abnormal condition requires the current operation to be aborted. Stop is a temporary hold of operations in progress. To ensure that the response to any emergency is systematic and standardized, we use pre-prepared emergency operating procedures or the EOPs. These documents provide step-by-step actions, clearly define responsibilities, and specify the sequence of reporting and decision-making required during an emergency. From safeguarding the seas above to mastering the depths below, the Indian Navy remains a critical enabler of India's march towards deep ocean dominance. Leveraging decades of operational expertise in underwater warfare, submarine operations, salvage, diving, and maritime domain awareness, the Navy can provide the crucial bridge between research and real-world deployment. The integration of naval operational expertise with scientific ambition will ensure that India not only explores the abyss, but commands it with confidence, resilience, and indigenous strength. With that, I come to the end of my presentation, leaving my esteemed audience with a thought to chew upon. From the murky waters to the deepest blue, to my God and the surface I promise this true. Whenever I hear the dolphin's distress call, I'll be there to rescue them all. Whatever the sea, whatever the depth, even if I have to stare down the eyes of death, my own life I would gladly give so that those who man the dolphin may live. Jai Hind, Sharomra.
Thank you so much.
Thank you, sir, for this highly motivating and inspirational talk. It definitely combines the real-life experiences with the requirement of a scientific explorations here. Thank you for walking us through the systems, subsystems of SRM, the crews and OIC's responsibilities, criteria of operations, and how Indian Navy operates. It's truly inspiring to see this. Let us take a couple of questions from the audience on this interesting talk.
Hello, sir. It's a highly motivating talk, and I want to know whenever that rescue vehicle is deployed, and suppose in submarine is in distress, you want to rescue the crews from submarine to this rescue vehicle, is it not? So how submarine and this vehicle is getting interfaced, because ultimately the interface is water only between that submarine and this.
So basically the DSRV or the Tiger 10 for the east coast and Tiger 9 for the west coast. So it's got two places or two hatches. The hatch which is on top is used for basic entry into the SRV. And there's a hatch which is below. This is a hatch which goes and mates with the hatch of a submarine. So once that link and a bond is established, I'll just use a typical layman language for it rather than going to the technical and the specific terms for it. So once that skirt and the hatches are mated with each other, that operation is called as a mating. So there's an interface which is established, the entire water medium through that is pumped out, and we have a vacuum which is created. The pressure is equalized with the submarine, and thereafter the hatches are opened, and once the hatches are opened, the rescues can be brought from the submarine into the DSRV. Okay. One important aspect to that is that before the hatches are opened, it is very critical to monitor the atmospheric condition, including the biometrics which are inside the submarine. Because possibly over a period of time, when a submarine has been encased or in distress, there might be a buildup of obnoxious gases, carbon dioxide, carbon monoxide. So the person who's going for a rescue might himself fall a casualty to it. So that becomes an extremely critical criteria. Before the hatches are opened, the rescues are brought inside, which are about 14 in number at a given run. And thereafter the hatches are shut, the DSRV demates and is recovered back.
And another thing is, see, it might happen that visibility is very poor or turbid water. So in that case, how you are, connecting the hatch, because might be 1 meter visibility range. The sonar is helping in that regards, and with that it is sufficient to, connect the hatches.
I completely understand the question and the worry. See, the DSRV itself is equipped with a sonar. It's got sonar, it's got a capability, it's got a visual port, viewport which is there, and by utilizing, and specifically before the start of a mission, all these conditions are gauged by the operations manager himself. If they fall within the limits of the no-go limits as was brought up in the presentation, thereafter the launch is commenced and the DSRV dives. Now during the period of dive, because obviously underwater we are not able to gauge as to how the conditions are going to be. We cannot know it while we are on the surface. So that's where the pilot becomes a deciding factor. And at every stage of the dive, because she does not go and travel much away from the mothership, just like it was brought up by Professor Vedachalam, that is a pinpoint operation. We know where the submarine is. And since this DSRV itself is a non-tethered vehicle which is there, we cannot allow it to go further away. So it dives directly down below and has to progress only for a small distance to reach a submarine, by which time the pilot can determine is it good to go or not good to go. How much are the currents? How much is the visibility? The cameras which are there on the DSRV, the sonar for the aids in navigation takes it through to the point where the distance of this submarine lies. And once it locates much closer, in case the visibility is really bad, then the operation is aborted, because throughout the entire time there is a two-way communication which is maintained, so that that tether which is not there, I'll say it's an invisible tether. The moment the pilot relays that it's not safe to go, the operations manager will give an order for recovering the DSRV and recommence an operation when the situation and environment stabilizes.
Okay, very nice. And another just small question.
Yes,
all that subsystems and other things, either is there any indigenization or it is completely imported till now? I mean, operational expertise, there is no doubt that Indian Navy is, one of the best Navy.
Excuse me. From the organizer's point of view, I guess in the interest of time, we may not be able to take further questions.
Sure.
We are encouraged to do it during the lunch hour. Let us conclude the session here.
Thank you so much, sir. Thank you.
Thank you, sir. May I request Deputy Director Dr. Ramesh to present a memento to Captain Vikas, sir. Sir, I request to present memento to Dr. Sir. Thank you, sir. All right. As we come to the close of the session, I would like to express our heartfelt appreciation to all our distinguished speakers. Your presentation have been both informative and inspiring, offering valuable insights into the latest advancements in subsea technologies, underwater robotics, autonomous systems, deep sea exploration and marine engineering. We sincerely thank you, each of you, for taking this time to share your expertise and for contributing to the success of this session. I would also like to thank our respected session chair for expertly guiding the sessions and fostering engaging discussions throughout the session. Finally, a sincere thank to all the participants and delegates for your active involvement, thoughtful questions and enthusiastic participation. Your engagement has made the session truly rewarding. Please join me in giving a warm round of applause to all our speakers and the session chairs for their contributions. Thank you. We look forward to meeting you again in the future technical sessions. Thank you. Please join us with lunch, sir.
Thank you very much, ma'am. I thank the chair and co-chair for their invaluable time in conducting the session. With this, we shall now proceed to the inauguration of Center for Marine Autonomous Robotics System, which we call CMARS, that provides the infrastructure to realize the future of underwater robotics and technologies that we have been discussing since morning. May I respectfully invite Vice Admiral Viswajit Das Gupta, NMSC, and Dr. M.V. Ramnamurthy, along with our director and other dignitaries, to kindly proceed towards the CMARS facility for inauguration. Volunteers are there to guide, sir. They will guide to the respective location. Thank you very much. Lunch will be served at Rajendra Chola Hall for VIPs and other dignitaries, NIT staffs at Manthan Hall, and for students at German tent. Kindly make a note of this. Lunch for VIPs at Rajendra Chola on the first floor of this, and NIT staff at Manthan Hall, and for students in the German tent outside the auditorium. Thank you very much for your time.
honored to have you, ma'am, with us today to share your expertise and key insights on autonomous systems and underwater robotics. Ladies and gentlemen, please join with me in welcoming Dr. Leena for her presentation. Over to you, ma'am.
Dear speakers, we will be fixing up to the time of 15 minutes. We are running short of time and we'll have to just maintain this 15 minutes and we'll go for a short question and answer session. Within 2 to 3 minutes, we'll just close the session as such. Madam, we can start now. Professor Leena.
Sure, thank you. I hope I'm audible and visible.
Yeah, you are audible, ma'am. You can go ahead.
Thank you very much and good afternoon to everyone. My topic that I am presenting here is on completed planning, control and learning for autonomous underwater navigation. I've been working on the embedded control systems and not only underwater vehicles but mobile and the aerial vehicles. So my methods are such that you are able to, the control allows you, does not need a lot of compute, but mathematical and theoretical guarantees are also involved while applying such kind of theory. So I will convey a newer method on integrating these planning, control and planning with the new framework that we have developed. Next slide, please. Yeah, so when we look into the world specifically, what we have is main challenges that we face here are the acoustic communication limitations. We already know that we are bound with acoustic signals which are low bandwidth, high latency, frequent data losses will happen. So, and of course the localization wise GPS access is denied. At the same time, from a mapping perspective, we know that it's an unstructured environment, very little features are available for navigation for us. And there is a lot of sensor limitations because we will be limited with the IMUs with the time. May I request others to be to mute because I'm hearing an echo here. Next slide, please. Sure. So the current practice, if we see from the controls perspective, is we work on, if we work completely on the IMU related navigation, inertial measurement related this thing, what we have is the drift available, and then control practices to under disturbances, how do we take care of these drifts and so on and so forth. Next, please. Yeah. And then we look into collision avoidance. These are all collision avoidance in these unstructured environments. We look into optimal planning, whether this path is good or that path is good, is somewhere we look from the either what is the optimality that we look for, whether it is an optimal time plan or an optimal path plan and so on. And then we come up with some kind of a reference trajectory where our vehicle should follow that particular trajectory and see to it that the reference trajectory is being followed and so on. So these are the current control practices. These are somewhere or the other. We kind of nurture our complete control paradigm over one or the other method here, and then look into the sequential handling of this somewhere. Next, please. So if we look into the navigational framework that is existing, somewhere there are decoupled plan and control methods, which are very formal methods, very well developed in terms of the independent planning part of it. Then comes the feedback control, and then we look into the safety part of it. Because then we start looking into collision avoidance methods and so on. And there, of course, we look into methods like trajectory optimization and looking into the left side of the slide, trajectory optimization, non-linear PID control, which are very powerful techniques. And I am rather more towards simplified way of control methodology, which is a very PID methods have been very much useful there. And then for collision avoidance, velocity obstacles methods, and so on. But when we start looking from the integrated framework, we have optimization methods, which are also motion set related. So in case of the optimization methods, we know the model predictive methods are very, model predictive control is very popular nowadays. And now for even avoiding obstacles, we come up with the control barrier function methods and so on. But when we start looking from the integrated planning control perspective, there are safe planning possible via natural motion sets. For example, when I'm crossing a road, I know that this is what is my safe. I don't look into whether, I don't pre-plan my path. These plans are coming automatically. It gets generated automatically as I move on. So we'll look into that part of it. And then there comes the framework, which is learning-based framework, which is right now being nurtured through the mapping aspects and so on. And that's what we will, of course, I'm not covering the learning part in the short time, but I'll trigger some points on it. Next, please. Next slide, please. Yeah. So when we summarize this vehicle navigation inside, we look into mapping, which is interacting with my localization module. Then it interacts with our path planning module, and the motion control comes later. And then, of course, path planning has two aspects. One is the obstacle path planning, and then the sensor-based path planning. There's a global path planning and there's a local path planning. Local means what is coming in the view of the sensors and so on. While from the motion control perspective, there's a high-level control and then there's a low-level control that we look into the thruster aspects of it. So when we start looking from the integration of these things, next slide, please. So what we can look into is what is the problem that we are kind of addressing here is integrating the problem by looking into the safe regions only. As I mentioned, we want to see when we are looking ahead of us, what is my safe region and what should I plan, which is also feasible from the control perspective. And that's why our approach is integrated control and learning. Of course, plan is already integrated into it. So then can I consider bringing up something which is giving me automated waypoint generation? So then, I mean, what I'm looking ahead is possibly looking into what should be my next waypoint automatically, instead of finding out, okay, that's my global path, global target, and then I look into, okay, the waypoint generation, waypoint being fixated to it. No, as we go towards the global target, what are the waypoints that I should look into? And going to the waypoint, the path is automatically generated, is what I am looking at. So when I say integrated, the integrated part is between the sensor-based planner over here and the high-level controller side of it. So as of now, I will just take that as a coupled architecture and explain that where is the learning coming up later, and then this integration of sensor-based planner and high-level controller, what is giving me? It is giving me a safe trajectories and which is automatically generated. I don't have to do in terms of the path planning first and then going over the reference trajectory. All right, so next slide, please. Yeah, so this proposed integrated approach, so of course we have extensively applied on the mobile and the aerial vehicles, and we have certain results in the underwater regions as well. So that's why whatever sensors you have sensors and actuator pack on your system. And at the same time, system means your underwater vehicle here will have its own motion sets. Means depending upon the thruster locations or the actuator locations, actuator functionalities, there are going to be certain velocity and the acceleration constraints, based on which I know that I can go in this particular area in whichever way, right? So which is control feasible ways of doing it. So that particular motion set, we will say these are invariant set for me. So I'll design a controller such that I will go into the, whatever happens, whatever kind of disturbances happen, my control will make sure that my vehicle is in this particular invariant set. And this invariant set is also the motion set of the vehicle. So that's why I'm able to solve this integrated planning and control problem. Whenever I'm giving a waypoint, I'm very sure that I'll be able to go there, because it is under the invariant set control based on the invariant set, and at the same time it is a feasible point where it is able to go. So that's what my integrated planning and integrated planner will do. Next, please. Yeah. So then I can divide my problem into 3 sub-problems. One coming from sensor, which is giving me an area, which is my safe region, means the free area which is going to be available for me to consider for the automated waypoint generation. From the actuator side, this is a motion constraint. So this particular entire free area, I will consider putting some kind of an invariant set such that my control is making sure that it is within that area. So this invariant set is what is my key area, and of course, since my planner is such that I'm making sure it is within the free area, it is making sure that it is safe enough. So these 3 coupled problems is such that the invariant set is the middle of it. All right. So let's see how it turns up. Go to the next slide, please. Yeah. So this is what my controller is. Of course, this is kinematic controller and whatnot. But of course, since I know that disturbances, it will be able to take care of it. This is 3-dimensional 3D controller is what we have. What this gives us is that my invariant set has some geometric properties such that it can be represented as a sphere. Okay. So my sphere is, so this particular controller is such that my origin is at the center of the sphere and vehicle is at the boundary of the sphere. So now this controller will take care that my invariant set is the sphere. So and the controller is making sure it is going to the center of the is making the vehicle to go to the center of the sphere, making sure that whatever disturbances are there, it will remain within that sphere, right? So that's where my possibility of making sure that it is a safe region that I'm going into. Next. All right, so this is what is a pictorial representation to go towards the target. So we keep on, whatever obstacles are coming up, we keep on looking into fixing up those spheres now. So the progression of these spheres as we move on, whether it is a small sphere fitting in, depending upon the free area available to me, or a big one, whichever free area is available to me, and keep going. And the vehicle, the vehicle will always go to the center of this. So you keep on bringing up these particular spheres, and the last point is going to lock the target. So now I can keep reducing my sphere whenever this locking is, and make sure that I'm reaching to this particular invariant, the particular target that happens here. So that's what my integrated planning and control algorithm is going to work over utilizing this particular invariant set controller, and it is always going to make sure that we are going into the center of the circles, center of these spheres, and the vehicle is going to always be within that particular sphere. So going via the narrow spaces or going because of the drifts, whatever the current location has moved to, it is all dependent on your local sensing, and you're fitting on this sphere and you keep on moving.
Another 2 minutes, ma'am.
Yep. Next, please. So we have applied 2 different scenarios. So this one is on the mobile vehicle. So for example, your bike is moving in a very crowded space, similar to our Indian bikers. So these red color vehicles are on the road, taken from the data set itself. They are following certain rule, but our ego vehicle is not following it. Please click on the image. It will take you to the video. And in this case, the invariant set is a cone, because my car-like vehicle cannot go up and down, yeah, or cannot go into the lateral direction. So my cone is my invariant set. All right. Please click on the image, please. Yeah, so you can see that this invariant set, this particular ice cone, is automatically being formulated, and depending upon the available region available to it. So now it has grown because it was very small region available to me, and now it is very targeted cone that it is going into, and it will reach to the target. It is not following any rules, but like Indian biker can go from one end to another end. That's the beauty of this particular algorithm. It makes its own path when it is moving. Now, similar to that, if there are junctions, of course these are simulation results, and it's using LiDAR. So if it's an L junction and the vehicles, each of the vehicle is planning to avoid the collision, it automatically does it by just a slight movement to it. The vehicle is using this integrated planning and control method itself. Similarly, if there is head-on collision with a dynamic obstacle, head-on collision here, one is able to do that. Okay. Yeah, it's a parallel crossing scenario. Similarly, we can show the other results. Can we go back to the presentation, please? These are more mobile vehicle related, but I have some underwater vehicle related results to show you. This is 2D planning and control, integrated planning and control. Yeah, next slide, please.
Ma'am, already time is completed. Maybe in a minute we'll have to close it, ma'am.
Yeah, so one last slide on the underwater vehicle side I would like to show the video on. Next slide, please. This is experimental result which I'll skip. Yeah, please run this video. Click on the image, please. So when it comes to the 3D planning, okay, so this is not playing. All right. So when it comes to 3D movement, there are the spheres that needs to be moved, and we have even applied it on the cluttered environment. The cluttered environment, these individual obstacles are moving in a very random manner. At the same time, the beauty of this algorithm that we saw here is when the obstacle that comes in the pathway, and it's a wide column kind of, then the vehicle automatically pitches and goes. So I don't have to make any effort, any new planning to be done. Similarly, if it's a long column that comes in, it automatically yaws and goes. So that's where the integrated planning and control methodology is helping in terms of preparing, you don't have to make your own plans. It makes its own because it is making the autonomous waypoint generation in this case. Now, where does the learning comes in? The learning comes in when we have the global information that we wanted to pick in. So those results are also available, which due to the paucity of time, I will just skip. That's over to you.
Thank you, ma'am, for the detailed explanation on integrated planning, control and learning for autonomous underwater navigation. Specifically addresses the acoustic communication limitation, GPS access and unstructured environment. Thank you, ma'am. I'm open. If any questions, please, one or two, maybe we can go through. Mike.
Thank you, Professor Leena. It was a very nice presentation. I am Pramod from NIO Goa. I just have a comment and a quick question that invariant set controller which you use seems to be a little conservative because it's more robust in terms of its for the safety point of view. But let's say there are not many obstacles and you really have to move in. Do you change the invariant set to make it more agile, or you? Because in that case you really do not need it and you can actually go. So either you switch the controller to something like MPC or something which are more which will give you agility in the vehicle. So just that comment, and if you can answer that. Thank you very much.
Thank you. So the exact, we compared it with the MPC results. So what is giving us here is for example, there is a location estimation, right? Yeah, because we will be working on the inertial measurements and so on. So there's definitely going to be drifts available. So in case of the drifts, right, now if it's an open space, my spare is the largest spare, right? So I don't need to plan it, I just need to go to the center of the spare. And at the same time, this is not using any optimization, nothing on that side. Because now I don't need to do it. So all these are compute, MPC is heavy on compute, while this particular method is rather easier to compute and so on. There are analytical results available to us. One thing. The second is, now when we compare it with MPC, the path length turns out to be similar. So I have optimality results also available. At the same time, it is working with when the location estimations appear, because now I'm looking into the region, going into the region, right? So that's why it's working.
Thank you, sir. Thank you, ma'am.
Yeah, and now we will formally start the second session on sub-vehicle demands. Ocean are increasing with the strategic security and scientific discoveries, in which more demands on the system is required. So we'll go through the sessions actually. Today the expert speakers are from Indian Coast Guard, NIO, National Institute of Oceanography, National Center for Polar and Ocean Research, Center for Marine Living Resource and Ecology, and Archaeology Survey of India. So we'll go with the first presenter, Commandant Deepak Karan Singh, who is also an electrical officer and from ICGS Sagar. His professional expertise in weapon maintenance officer at ICGR Vijaya and also ICGR Sahar. He is also EXO at ICGR Carver and ICGR Minikoi. So over to you, sir.
May I have your attention, please? Respected Vice Admiral Biswajit Das Gupta, National Maritime Security Coordinator, Rear Admiral TVN Prasanna, VSM Joint Secretary, Professor Dr. M.V. Raman Murthy, Mission Director, Professor Balaji Ramakrishnan, Director NOAT, and all other distinguished guests, a very good afternoon to all of you. Today myself, Commandant J.G. Deep Karan Singh from Indian Coast Guard, going to give presentation on coastal surveillance in next 10 to 15 minutes. Coastal security construct in India. Scope of my presentation is as follows. Introduction, genesis of coastal security system, CSS, coastal security initiatives, law, legal parameters, constraints and drawbacks, recommendation, suggestions, and finally ending with a conclusion. Why coastal security is needed? Introduction, as flashed, coastline of 7516.6 kilometers, 9 coastal states, 4 UTs, vanguard of development, 1334 islands, 2 prominent island groups, Andaman and Nicobar and Lakshadweep. India's maritime stake. We are having 12 major and 239 minor ports. Coastal assets, as flashed, 3 out of 4 metros, India's financial center, ports, industrial units, military installations, oil refineries, nuclear power plant, offshore development, investment and infrastructure. Now coming to the maritime threats, terrorism, sabotage, piracy and armed robbery, arms trafficking, human trafficking and illegal migration, contraband smuggling, drug trafficking, maritime crime and fraud, environmental crimes, poaching. The genesis of coastal security. Past development. Coastal security concept formulated aftermath 1993 Mumbai blast. We all are aware of it. Smuggling of explosives through Raigad coast, Ops van launched, joint Indian Navy and Coast Guard patrol across Indo-Pak border, layered security. Coming to the post-Kargil war, circumstances changed a lot. Security and surveillance of long coastline caught the attention of group of ministers. Several measures were implemented by GM in a phased manner. Implementation committee as flashed. Now coming to the committee recommendations. Government measures include border management division in MHA, setting up additional CG stations along the coastline, setting up of chain of static sensors using existing lighthouses, setting up of marine police in all coastal states and island territories for policing up to territorial waters. Post-Kargil war, GM also recommended enhancement of intelligence mechanism, setting up of multi-agency centers both at center and state level, MEC and SMEC. Measures for enhancing the security at seaports. Hub and spoke concept, coastal security scheme was implemented in a phased manner. What is coastal security scheme? CSS launched in Jan 2005, implemented in phased manner across 9 coastal states and 4 UTs. MHA formulated hub and spoke concept, multi-layered surveillance, Indian Navy beyond 12 nautical miles, Indian Coast Guard from 0.5 nautical miles to 12 nautical mile, Marine Police, CSPs, Custom and Port Authorities less than 0.5 nautical miles. Objectives of the CSS: strengthening infrastructure of Marine Police force for patrolling and surveillance of coastal areas, particularly shallow areas close to the coast, establishing institutional arrangements at state and district level for coordination among various agencies. Coastal security scheme under phase 1 as flashed, which is having the outlay of rupees 646 crore, 73 coastal police stations, 97 checkposts, 58 outposts, 204 boats. Scheme completed on 31st March 2011. 2611 Mumbai Tech, wake up call. CCS directives on 16th Feb 2009. Indian Navy designated as authority responsible for overall maritime security. ICG additionally designated as authority responsible for coastal security in territorial waters, including the area to be patrolled by the coastal police. DG-ICG has been designated as Commander Coastal Command. ICG responsible for overall coordination between central and state agencies in all matters related to the coastal securities. Expeditious and time-bound setting up of static control radar chain. Coastal security scheme under phase 2 as flashed. Present coastal security scheme, Marine Police already briefed up to 5 nautical mile, ICG 5 to 12, Indian Navy beyond 12 nautical miles. Initiatives by ICG for coastal security. Chain of static sensors. Contract between ICG and MS Bell concluded on 8 September 2011, designed for round-the-clock surveillance all along the Indian coast to monitor the highly sensitive areas and high traffic density of ships bought through the remote stations. Standard operating procedures. ICG formulated SOPs for each coastal state UT in August 2009. Prime objective to achieve seamless coordination amongst participating agencies. Coastal security exercises. validation of SOPs. We are conducting Sagar Kavach exercise twice every year for each coastal state UT to ensure preparedness, coordinated by ICG through SCS OCs. Scenario exercised, infiltration through boats, ship hijacking, attacks on port, tourist places and coastal. Contingency plan was made and CMG was exercised. Debrief chaired by Chief Secretaries. Ops Sajag, special operation named Ops Sajag, conducted every month. Boarding operations, one among the many charter of duties. Boats checked toward carriage of registration paper, fishermen biometric cards are checked, and life-saving communication equipments are also checked. CIPs are conducted. Awareness about the safety issues at sea is being told to the fishermen who are at sea. Welfare measures, including medical camp, sensitizing on prevailing security situations. Now coming to the coastal security network, radars, electro-optical sensors, which is having CCD cameras, LLTV, thermal imagers, VHF communication, MET sensors, AIS, networking equipment with VSAT overway. Coastal security network in phase 1 as flashed. Coastal security network phase 2, additional sites to achieve near gap-free surveillance. Phase 2 of CSN for 38 sites and 0 mobile sites approved. VTMS connectivity at Gulf of Kutch and Gulf of Khambat. It is completed in 2019. Indian Navy, GOCs set up at Mumbai, Vizag, Kochi and Port Blair. GOCs jointly manned by ICG and IN. 1,000-man Sagar Prahari Bal constituted. Existing naval CNCs designated as CNC Coastal Defense. National Command and Control, Communication and Intelligence. Integration of input from surveillance, navigation and intelligence network. Common Command and Control Grid. Efficient decision support tool. NC3I model, which is having total ICG 31, IN 20, total 51 sites. National AIS chain as flashed, phase 1 74 sites, phase 2 13 sites. Now coming to the long range identification and tracking, LRIT, initiated in accordance with SOLAS, system envisaged auto transmission of position data by ships every 6 hours up to 1,000 nautical miles from coast. System ensures longer surface picture availability. International Ship and Port Facilities Security Code, ISPS. IMO in November 2001 passed resolution to develop new measures relating to security of ships and port facilities. Same adopted by conference through amendment in SOLAS Convention 1979. Implemented in December 2002, all Indian major ports brought under ISPS code. Fisheries Registry, Real Craft, online application system for registration of all fishing boats under MS Act, complies with MS Act and license certificate under MRF Act. Project sanctioned by the DOHDF, MOA, Government of India, data available online for security forces. Uniform color code is there for fishing boat identification. Government initiative to facilitate easy identification to make stray boat identifiable. Fisheries identity cards, part of Nation Marine Fisheries Database, NMFD, for access by all authorized government agencies. Intelligence and information, MAC at Delhi and SMAC in every state, 24/7 control rooms for counter-terrorism, timely sharing of information and better coordination, int agencies, nodal officers of 25-member agencies, meet Delhi, LIA, ICG nominated as a lead agency for coastal and sea borders, provide institutional arrangement for coordination and sharing of intelligence among various agencies operating on the coast, conduct LIA meeting to collect and disseminate the intelligence information. This is a toll-free number 1093. Information distress on coastal security to police control room at the state district police headquarters. Security of the island, PM directives on development of island, inter-ministerial task force under MHA to work out development and security issues for the islands. MOD and ICG are members of committee. Now coming to the law and legal parameters. Powers of the Marine Police. The Coins and Currency Stamp Act, the Arms Act of 1958, Explosive Act of 1884 and 1908, NDPS Act of 1985, Foreigners Act of 1946, Indian Passport and Immigration Act, Petroleum Act of 1934. Now coming to the powers of the Marine Police, the Benami Transition Prohibition Act of 1988, the Karnataka Excise Act of 1965, Karnataka Forest Act of 1963, Indian Passport Entry into India Act of 1920, the Passport Act of 1967 and the Immigration Act of 1983. Empowerment of ICG, MS Act 1958, Custom Act 1962, CRPC 1973, MZI Act 1981, NDPS Act 1985, SUA Act 2002. Crimes in Indian EEZ. 10 police stations have been empowered to register and investigate crimes committed within the country's exclusive economic zone. 10 places of trials as shown on the slide. Charges against 26/11 terror attack. 86 charges, major charges, conspiracy to wage war against India, collect arms for waging war, commission of terrorist act, conspiracy to commit murder, committing murder of a number of persons, attempt to murder with common intention, abduction for murder, robbery, dacoity. Now coming to the constraints and the drawback. Highly complicated maritime environment required large number of surveillance assets, highly expensive in capital and operating cost. Increased traffic with problem of identification, highly porous IMBL, easy to infiltrate IMBL due to ethnic and geographical similarities. Overlapping responsibility, lack of institutionalized presence in GOCs, institutionalized secured communication among stakeholders, lack of resources, non-effective fishery surveillance. Now coming to the way ahead, enhancing accountability, enactment of Coastal Security Act, Maritime Security Authority. The conclusion, greater awareness among various fisheries regarding CS, SOPs promulgated for each state help in resolving issues. CS exercise coordinated by ICG helps in launching of coastal security operations in shorter time. Greater synergy witnessed after each coastal security exercise operations. MAC, force multiplier with seamless flow of info. Next. Jai Hind. So here I conclude my presentation pertaining to the coastal securities.
Thank you, sir. We are honored to have you here as a speaker and significant contributions to the nation. Especially you have detailed on the coastal security scheme and its thing, which is a remarkable contribution. And thank you, sir. Any questions? 2 minutes each.
Thank you.
Sir.
Thanks for nice presentation. Because it is regarding the coastal surveillance, which is very.
Yes, sir.
It's not that simple in our coastal long lines and all.
Yes,
But
sir.
still,
Because, sir, please.
Still, actually, as a maybe a right question or not, I don't know. Suppose a ship comes in the international water, and they put some underwater vehicle which moves in with some hazardous material or something coming inside our area. So right now, what kind of preparations or any techniques we have in Indian Coast Guard? Can you give some idea?
Sir, while we are patrolling, sir, I am actually on board ship, only capital ship as electrical officer, sir. So while we are patrolling, sir, on our that water borderline area, so we are inspecting each and every fishing boat. Our boarding team is there. We are checking for any contraband with them. We are checking their cards. So nothing like that. In many times it happens, boats just cross, either willfully or whatever they tell when we caught them just to catch a good fish. So they mostly cross the borderline. Same goes for us. Our Indian fishing boats, they cross. Same from the other side, they come to our Indian territories. But we are not allowed to cross our territorial waters. But our borders, they are fully manned. Nothing problem in that, sir. And this issue mostly is sorted out after the Mumbai attack, sir, because the terrorists choose this option only. So after that, patrolling is 24/7, sir. One ship if leaves the area, another ship is there continuously patrolling. And India is the only country where we are having the longest coast, starting from, you take from the Gujarat, coming to the islands, and then coming up to Odisha side. Sir. Thank you so much, sir.
I just wanted to elaborate his question only. When normally your ships have equipments, correct? You may have sonar or something so that if somebody is underwater swimming or diving and trying to get into some area, so you detect.
It will be detected.
So
it
you
will
have
be detected.
sonar, all the kind of gadgets already there on your Coast Guard.
Understood,
ship,
sir.
Right? Yeah, thank you.
Yes, sir. It will be detected. And in case any such thing happens, we just, our boarding party who boards the fishing boat for searching, we just arrest and then bring it on our ship and then came back and take the further procedures, how to tackle them. Thank you so much, sir, for the question, sir.
Yeah, if no other questions, I request our Deputy Director.
Hello, I am Commander Vivek Singh. I am retired. Just to elaborate the sir what have I asked about the underwater vehicle if coming to our area. So as we understand, our water profiling is very low, where detection of the small vehicle is very difficult, especially in the case when the vehicle is coming near the port or any of the harbors. We have a integrated harbor defense suite installed in majority of the port, where the any portable vehicle coming, it can be detected, as well as the even the person who, or the diver detection sonars and everything is there in terms of active as well as the passive sonars, which can be detected, and port is remains safe. So on the open sea, the smaller vehicle, detection of smaller vehicle is quite difficult. Definitely Navy is progressing in that direction also with implementation of lot of towed array sonars, where the low frequency sonars is being integrated for the detection of longer ranges of the smaller system, as well as the ISR missions, which Navy is also taking care with the help of AUVs. But near the coast, definitely the integrated underwater harbor defense suits does the purpose. Thank you.
Thank you so much, sir, for elaborating on this.
Yeah. May I request our Deputy Director to give a token of appreciation to Commandant, please.
Next, I call upon Dr. Pramod Kumar Maurya, Senior Principal Scientist, CSI, National Institute of Oceanography, Goa. His major contributions to India's indigenous Tejas light combat aircraft program, developed ground checkout systems, flight control laws, aero servo, elastic validation systems, especially in marine robotics and AUV contribution. He has designed guidance system for remotely operable sea skimmer. His contributions to Maya, India's first autonomous underwater vehicle, project director as deep sea AUV for 6,000 meters ocean exploration and a deep ocean mission. In terms of research achievements, he got NRDC Meritorious Innovation Award for Autonomous Vertical Profiler, contributions to international projects, GRIX and MOF, developed coral reef monitoring robot for marine ecosystems. I invite Dr. Pramod Kumar Maurya to discuss subsea platforms for exploration and resource assessment. Sir, please.
Thank you very much for such a good introduction. Respected Director of NIOT, distinguished naval officers from our esteemed Indian Navy, my colleagues from NIOT, and all others who are gathered here. It's a pleasure that you invited us to talk a little bit on resources, and which are very important, for which all of us are now working toward. So I will give a glimpse of ocean research and the resource exploration, and a little bit of what NIO is doing on that, and then what kind of technological challenges the science poses on us, so that we are able to, it's coming there, okay. So what kind of challenges is the scientific community posing on the technologies to come out to solve many of those scientific problems? For those who do not know, I come from National Institute of Oceanography, which is in Goa. It has 3 more centers in Cochin, Mumbai, and Visakhapatnam. And our mission is to continuously improve our understanding about the sea around us and to translate this knowledge to benefit all. The last few words are very, very important. So why are we looking at the resources? If you see from all that point of view of exclusive economic zone, and this map shows exclusive economic zone, a tentative map of almost all the countries, and you see that India has a very, very big exclusive economic zone and large ocean area with vast living and non-living resources. So this poses us a very good scientific and technological challenges, that how do we cover our exclusive economic zone in order to explore and sustain utilization of the resources which we find there. When it comes to the research of ocean science, is not just one thing. When we talk about making an AUV, we only talk about a few subsystems of that. But when it comes to the ocean as a whole, it has almost all the branches and interconnection between all the disciplines. And these all are being studied at multiple institutions, and NIO also has all of these branches on which now we are working in terms of active research, which are again related to societal benefits. So in terms of covering the resources, I will take into 2 parts, non-living resources, 3 of them, gas hydrate, hydrothermal vents, and very close to us, which is our flagship program from 80s, polymetallic nodules, and then a little bit on living resources and archaeological research, what we are doing at NIO. So for those, many of you know very well, but for those who do not know, gas hydrate is something which is lying at the seabed, and it has a very high potential for solving the energy problems for us for decades. And just for an example, if you see that 1 cubic meter of hydrate has 164 cubic meter of gas in it. So this, if we are able to tap this in some way or the else, this will solve the energy problem of our country for decades. And if you see that from 1981, the first gas sweep was detected, and since then NGHP was formed, and then we found especially these 5 sites which you see there. That's where around the Indian Ocean we have these gas hydrates, and one of them has a very high potential, for which the next expedition of NGHP-3 is going to be a pilot production test. These are massive energy resources, and they require tools which are very efficient in exploration of these. So these are and one thing to tell you, that they are stable only at high pressure, and they pose a very big geohazard. If they are brought up, a lot of methane will get into the atmosphere, and this is a greenhouse gas which is going to cause a havoc for the climate change. So if you take a very simple example, image taken from approximately 60 to 100 meter above by using a multi-beam system, and then you have the one which is taken from 10 meter to 15 meter above, and you can easily see the resolution difference, and one almost looks like an acoustic image, which looks like an image there itself. So we require tools which to estimate it better, such that these can be much better way explored and found out the quantum of that. And not only that, how do we monitor the geohazard? How do we map this? What kind of systems in terms of technology we need to put in there? Then hydrothermal vents. These are another good source of sulfide, which we call it, and they are at the depth. In India, we are at the depth of approximately 4,500 in Central Indian Ocean, if you go even beyond that. And some countries are lucky to have it at 40-meter water depth. I happened to dive in that at Azores Island, which was very interesting. This is a superheated water which comes from the underneath the ocean. When it is very hot, very, very hot, it comes at very high pressure. Objective is very simple: find and map these vents. Now, if we go for a kind of, if you detect it and you want to claim that this area to International Seabed Authority that we want some right to explore this area or to sustainably utilize the resources there, then you need to produce photographs. And without the technologies, it is not that easy. If you see that with the help of the ship in Indian Ocean, by putting the CTD operation, looking at the turbidity and trying to find out where the plumes are, which are the proxies, and then the countries which has the technologies would go there and find out and claim that as a part of their ISA, which is International Seabed Authority, would give them a contract to do that. In fact, we have a 2016 to 2031 polymetallic sulfide exploration contract, which is renewed last year for 15 more years. Now, here what the research focus should be, that how can we use this technology to geochemically map the Indian Ocean, especially the areas which we think, and more to map. And then how do we find out the biology related to this, to estimate its abundance, whether it is really worth extracting those minerals from there or not. You need to look at a very, very close distance, these things. And that requires a kind of a technology which you need to go very close to that. And then if you see polymetallic nodules, and many people are very well aware that these are, potato-shaped, which are lying at the sea floor. And in the first nodule from Arabian Sea, 1981, till today, then we got the first mine site ready for us to go and explore. This time taken, if you see from 81 to 2017, and the amount of people which were involved, 2,500 days, 72 expeditions we had done in this. And can it be reduced? Can the technological challenge be such a way that we can fasten this process and do more optimal? And we are able to actually find more areas which we can actually get into into the rights for that. So key challenges here: can we have multi-agent AUVs which can go there, find out? Can we have a real-time nodule abundance analysis using AI-based tools? Do we need to have benthic observations which are continuously monitoring for rapid EIA, which you need to do before? So if we use a system and we are actually going to harm the environment, then again it is not sustainable. Can we come out with technologies which are more sustainable? And here is an artistic rendezvous of multiple AUVs without disturbing the ecosystem. Can they pick and kind of a virtual conveyor belt, and which can take it. I mean, this is just a thought, but we had to do brainstorming among the engineers about what kind of best technological methods which we can find to do that. Then we have cobalt-rich crust, which is shallowest at 1,700 meter to 4,500 meter. We need to look at very high resolution images again there, find out what is the abundance of it and how we can find out these resources and extract them. And again, then the living, this is the two pumps which you talk about for the living resources, ocean biological pump and the ocean physical pump, which with our lifeline is running because of this. Most of the carbon dioxide has been taken down with this system which is happening. So do we study in terms of research what's happening at different layers? Very little we know about it. And can we
use technology in such a way that at every layer of it, we are able to more critically understand, so it becomes very easy for the sustained utilization of the resources. So if you see this map, this is the Indian Ocean, and if we want to explore this, and this is our, let's say this is our dream to find out a lot of stuff which is already there. The number of ships which we have, the number of institutions which we have are not enough. We require more number of, and ships just like that cannot be used. We require more autonomous tools which can be there, which can be doing faster surveys, and more technological tools which would be there. So if you see the bigger point of view, I use this, using AI, I generated this image. So if you see the ocean exploration is not just AUV, not just ships, we have to look at a wholesome picture in which you have systems which is profiling, in which we have AUVs which are doing close short-term surveys, we have gliders and satellite data, and then when all of this data is coming, where is the place where all this consolidated data is looked at to give us a much bigger and a clearer picture. So that's again another technological challenge with AI building up, because humans sitting down there and looking at all the data, publishing a couple of papers is not enough. Then again in connecting to the history, our past history through maritime activity, and IO is very much involved in maritime archaeology investigation, Dwarka, Mahabalipuram, Pumpuhar. I've been very active with our archaeological team in diving as well as providing the technological support to look at. So these are some of the things which we did using ROV and use USBL to find exact locations of those. And not only that, because you cannot bring those artifacts out, so can we actually create a photogrammetric thing using AI tools to create a virtual museum so that the future which is coming, the students can see that what is down there, because not everybody can really dive. Then what kind of tools do we need in order to meet those scientific challenges which we have? So I categorize them into two parts. One is the fast survey methods which we use, where you have AUVs, ROVs, and profilers, and then we have sustained presence at the sea, where you have systems which can be doing profiling continuously for years. And there are systems which can just listen to the sound of what is happening and tell you what kind of different biodiversity or different kind of organisms which has come there and passed by. I'm also involved with India's new CSIR mission mode project, Deep Sea AUV. This is work of many in true sense, because here NIO, CMERI Durgapur, CIRI, NCL and SICRI are together working to make this. 1 year of this project has already been over. We have 2 more years in order to first go for the first phase of this project. So this is in first phase, we are building a capacity such that we are able to go down to the depths which we want to go and carry some basic instrument. And then in second phase, we want to actually do science, because we are doing all these AUVs for what is the purpose of doing it. That's the main question. So if I make an AUV, why I am making this? What is it going to do? And that is when people are now talking about 300 days, 500 days at ocean, and we are still talking about the little controller which I have built for this AUV. So what kind of, can we carry a mass spectrometer down there at the hydrothermal vent and say much bigger information than what we do it? So these are the kind of questions which need to be asked to the engineers. And in this case, we are doing it in 2 phases. First phase going to 2,000 meters, second phase 6,000 meters. How do we optimize an energy that while you're going down, you do not utilize the energy. You go free fall, drop away, do the mission, come back up. A lot of details which we can discuss during the dinner time. But those are not enough. You also have to have shallow water needs to cater. So this was one of the India's first AUV which NIO did in 2006 called Maya. So I'm not going to take so much of time. With the help of submarine design group, Indian Navy, we did upgraded Maya, called it Jaya. This was instrumental here was Commodore Amit Ray. And we did this. We are doing an endurance test there where you deploy the vehicle, keep it there and run it till the battery lasts and see actual time how much it is going. Some sea tests have been done. Now we have to take it to Lakshadweep to do for 200-meter water depth. Coral reef monitoring bot, these are the one because every time you're taking human divers down there, and divers will have to do a line transact method, and they will always dive in 2. Takes a lot of time to do that. Can we have a bot which can do the same line transact method and use AI-based techniques in order to estimate the coral abundance and all that? So this was also transferred to KDIL very recently, last year.
and now we are thinking of having one unit from them and start operating in Lakshadweep. Systems which can be kept at the sea, left there, taking images. One of the biggest challenge in terms of scientific challenge in terms of coral is estimating the size of the coral to at level that every 6 months or 7 months you can say what is the growth. So that is the kind of, if you want to look at, so that is the kind of 3D photogrammetry has to have that kind of accuracy in terms of few square centimeter changes in the coral reef. So we can have a system which can be just at one place, looking at the community, transmitting the images back to your institution, and there is an AI system which is going to do that estimation for you. Then human-robot interaction, this idea wherein archaeologist wants to go down and they carry a lot of tools with them. Is there a bot which we can do? So using these are like kind of a software which we can work on. India is very good at that. And we use the simple hardware of Blue ROV and train the network to communicate with the diver that you do a survey here and I will do something else, or follow me, maintain a certain distance, take this item up back to, and all kind of. So here also AI-based approach to help archaeologists with it. So this is long-term deployment of SREP. This was deployed 2 times for almost more than a month, 35 days at the ocean of Gujarat. And you can see it can give you information which satellites cannot give you, that what is happening at 50-meter depth of chlorophyll and how things are changing over the time just at one place. The other systems like bio-inspired vehicle, I mean, why we need, this is also for the long term, and this we are talking about saliency now, where the vehicle decide by themselves. So you leave them in the corals, they are sitting down at the bottom, and they themselves decide when to wake up, when to you hear for a kind of calls, and see where is the hotspot for sound is, where is the hotspot for the images. So biodiversity, hotspot detection, that's the application of this kind of bots, and they can easily disguise because they also have very small size and kind of material which you use, they can be used for the strategic applications as well. You see this is one of the prototype which was developed at NIO with our scientists. So it moves more not like the screw-based propeller. It moves its fins and it's fully actuated because it can go in every direction. And you see here it is diving down. It can sit at the bottom and changing a little bit of buoyancy. You can lift up yourself like organisms which use tide currents and all that. Thank you for your attention. If you have questions now, I can answer now or during the dinner time if the time permits.
Thank you very much for the wonderful presentation. So you started your talk from gas hydrates.
Yes.
So just for the information of the audience and for you also, actually you can add in your future presentations. We have an autonomous scoring system. So maybe you can add it in your presentation in your futures. Actually it is capable of going up to 3,000 meters water depth, and it is basically designed for ground truth evaluation of the gas hydrates, which can drill a hole of 100 meters from the seafloor. And it has drilled almost 106 meters from the seafloor, and we have found some traces of gas hydrates also. Thank you.
This presentation on that last robo on the tank, like a tortoise, how the buoyancy is getting controlled over there?
So right now this uses only the propulsion to go down, but we are changing using a very small bladder. You can change the volume of the bladder, and then you could say by filling some oil into this, taking it back. So by that we will be able to change. So here, because the size is very small, the change in the volume is very, very small. A few tests were done with a very frugal kind of buoyancy engines which we have made, which are piston based. No, pump based, but not really. Right now what test we have shown is only using the propulsion, it is going down.
Sir, how about biodegradable or underwater soft robotics? You are exploring for that area? Or?
Yeah, we have not been working on any of that. The new person who has worked on that biorobotics from material science, so that is where this thing has started. but no, nothing biodegradable. We thought of that you throw something very small in the ocean and over the time it transfers you the data and slowly disappears, but no, really, no work on that.
Okay, thank you.
If no questions are there, we'll close that.
Yeah, thank you for your presentation, sir, within the time. And may I request our Deputy Director for giving away a token of appreciation to sir. We'll go for the other presentation. It will be from Dr. Jensen George. He's scientist E, Ocean Science Group, National Center for Polar and Ocean Research. His academic, he has done his MS in Oceanography and PhD in Marine Science. And he was a former NIOTian. He's a project scientist from NIOT and a consult scientist from IISc. His experiences on ocean turbulence and ice, sea, air interactions, polar oceanography, and area of focus is on development of advanced ocean observation methodologies, exploration of polar marine environment using autonomous systems, strengthening India's scientific capabilities in Antarctic and ocean research. He is leading operations of PRICE, Sea Ice Observation near India's Antarctic station, Bharati. Over to you, Dr. Jensen.
Yeah, thank you. Hello, everyone. What you see in the screen is 2.5 meter thick sea ice drilled to access the water beneath. So just to show a perspective of what it looks like from the water to up. So we are the new kid in the block regarding underwater robotics because we just started using last year. So from an oceanographer perspective, the purpose of ocean robotics is accessing oceanic regimes that remain inaccessible through traditional means like sea ice covered regions. And the other important part is measuring different length scales, which again does not happen with ship alone. So here particular interest is sub-mesoscale and down. In the turbulence scale of millimeter scale of ocean observation, this era is good because we have better digital signal processing, better electronics, so that any platform with a steady sinking or lifting up can measure turbulence. What difficult is 1 to 10 kilometer scale of observation because that process evolves in hours. So it has to go fast, cover fast, and the large scale is also easy because it has satellite and mooring and ship-based observations. So in the history of Indian observation oceanography, in 2014 and 15, Professor Sengupta and then Ravichandran from INCOIS did a cruise of ocean monsoon and mixing. This is the first time they targeted sub-mesoscale processes using something called UCTD, underway CTD. What it does is that it's a small CTD which goes up and down when the ship is moving. So basically you are getting high resolution temperature and salinity profiles of the order of 1 kilometer to every 2 kilometers one profile and so. What you can see is that the top panel of shade is basically density. So when there is a density gradient and the denser side always sink down and the less dense region upwells, and eventually it slumps to the dense region. So basically entire process of this submesoscale process is decided by the temperature and salinity gradient. So oceanographer always looks for very good measurement of temperature gradient. So this was their method of chasing friends, submesoscale friends. During 2016 July, Professor Vinay Chandran from IISc again, with UK collaboration, they had a different perspective. Instead of chasing the front, let the front come to you and use observations to capture each tense in the mixer layer budget equation. And what they found, again, 10 kilometer scale of, length scale of process are important in temperature evolution. Now, coming back to Antarctica. Antarctica, we can't implement both these methods. I was fortunate to attend both these expeditions, all 3 expeditions. And in Antarctica, we can't do surveys like previous expeditions. The reason is that there is ice-covered region. And we have only small window of the wake of the ship to operate this so-called UCTD. And so what we did is designed is that we know that the coastal water is fresher, colder compared to open ocean. So the gradient is always perpendicular to the coast. So our entire track was designed perpendicular. And this also gave a good idea about the frontal structure and the temperature gradient and salinity gradient. So in the color scale, in the color bar, what you see is the background is the model salinity and model temperature, and what overlaid is what we observed at very high resolution. And you can immediately notice that the freshening, the melting of sea ice or iceberg or all other features are very much underestimated in the model, and observations are very much needed. And this is one of the need of ocean robotics, where we need high resolution measurement. In 2025, we started our first deployment of glider. And if you notice the track, the left panel, it's straight line, because we don't want to complicate our first observation, first ever deployment of Indian glider in Southern Ocean. So, so we kept it simple. But the operation was not simple, because we were operating from a cargo vessel which is of 200 meter long and 20 meter height from the sea level. So it is very difficult operation. Our deployment was pretty much classic textbook style deployment, wheel lowered through a boat. But when it was recovery time, we noticed that it was not rough. The wave height was so much, it is around 7 meter. And no boat can go in a 7 meter high height. So recovery was difficult. I was just thinking, if we had a docking mechanism, it would have been much easier, and we could have done a very sophisticated ocean observation experiment with this glider. Now look at the world. This is a 2022 and 2024 expedition called SASI. It is meant for salinity stratification and sea ice edge. The same process, looking for sub-mesoscale fronts. Look at the infrastructure and the automated instruments they have. The technology is there in India, especially with NIOT and NIO, it is there. But, and look at the track. The moment ocean observation track is complicated, it means we have a capability of ocean robotics imbibed to the system. So I particularly like to focus on the jet SSP, which is we want to implement in our expeditions. This is nothing but a kayak, motor kayak. Again, you can tow it, but it should not be in the wake. So the propeller in this kayak is only meant to keep away from the this thing. This also gives very high resolution surface temperature and salinity gradient. And this we would like to explore for in future. Now, mooring. Now we talked about 10 kilometer and turbulence scale. Now it is long scale, mooring. Now this is an Arctic mooring. It's maintained by NIOT. It is the best collaboration India has ever seen last 12 years, going good. Now, when we want to do a CS observatory in Antarctica, we had mind to go with the INDARC. But the problem is that the sea ice is fully covered. How to deploy a mooring? And you can see it is very unpredictable when sea ice breaks. It just washes away. So the way we solved is that we simplified the system so much that we just hanged everything on the sea ice, because sea ice is a very good buoy. It works like a buoy. And so it is also going now 4th year of the mooring. It's a very simplified mooring. Entire system is hanging in the sea ice. But we have to redesign this mooring. Reason is that hydrographically it is good. We are getting interesting result. We are getting warming in some year and cooling in some year, and this warming is because open ocean waters are somehow reaching. We want to redesign this experiment, sending the entire instrumentation under the ice. But still we don't know how to pick it up when time comes. Deploying is okay, because we can drill a hole and then send it. It is Again, the sea ice hanging mooring has another problem, that it is heavily contaminated with the atmospheric variability, because sea ice moves and the system moves. But this movement of sea ice also helps biologists. This is how under the ice looks like. There's a paddy field, analogy is paddy field down below the sea ice. There are ice algae, and if you take the ice core, you can see there are algae there, and this is growing, and this is important component of blue carbon. If you look into the water column chlorophyll and sea ice chlorophyll, you realize that sea ice feeds the water column, and it can create under ice blooms. And from satellite, there is no observation. So, and if you look into the, it is a downward looking ADCP, and this is the aqueous intensity. You can see how the sea ice algae eventually falls down to the bottom, and bottom there is a flourishing benthic organism. It's really good. But our only problem is that biology is controlled by light, and we don't have any way to measure light, because if we drill a hole, the entire ambient light is contaminated, because you can see from the below the above the ADCP, light is coming from it. So measuring that light doesn't make any sense. What phytoplankton or algae feels is important. Now here in 2025 again we introduce a ROV. We particularly kept it very simple. Its objective is only one thing: go under the ice, look upward, look downward, and go under the ice shelf, icebergs, etc. The purpose is very simple. How did it perform? As a platform, it performed really good. We have good visuals. We went under this iceberg also. It is good. Where the problem came, the ROV doesn't know where it is, because we are losing the track of it. The DVL, dead reckoning, is working quite okay because it's shallow water, but the USBL is not working. And we are working on it, and the OEM performed some upgrade, and now it is working. We believe that it is working, so we will test it again. Another problem is we are getting like 4 hours, 6 hours of footage of lot of benthic organism, and we don't know what to do with it. So eventually these images has to convert it into data sets. So that is where new research and new integration of artificial intelligence is required. Now our short aim is that eventually we have to bring a lot of Indian technology to the expedition, with which we can do observation near iceberg, ice shelf, and sea ice. And I believe that NIOT has most of this technology. What we don't have is a technology where we can measure the water temperature and salinity from an aerial vehicle. You can drop it, it can be portable, it doesn't matter, but we don't have that technology. Rest, we have everything, especially the surface boats, ROVs, gliders. We can include many operation and conduct a very good expedition. That's a short game. And in long term, we want to increase the imbibing of ocean robotics to our observational workflow, and we want our robots or underwater vehicles to be a little bit autonomous. That's it. This is the ROV which we used. And by the way, this is a Make in India ROV. It is lightweight, it's only 30 kilograms. So what we noticed is that even though the entire region is covered in sea ice, within 50 meters the substrate change and the benthic flora and fauna is changing drastically. Thank you very much. That's it.
Any queries?
Thank you very much for a very exciting presentation. The underwater images that you showed, is it taken from an ROV or how it was taken? The underwater grass images, under ice?
It is ROV. ROV.
ROV, okay. Which ROV you used?
We used the iROV that we recently purchased.
From our
Yes.
Cochin?
Yes, Cochin based.
Okay. So the images were very good, actually. That's why I asked. Okay.
Images were not good. We had a lot of help from, a lot of improvement is happening that way.
So
yes.
you took the images and later on you processed it?
No, we don't have much engineers with us. I'm a physical oceanographer. I operated it. No, I didn't do image analysis. What I meant to say is that, so we had contacted with, like Maurya sir is there, and many people are there, so they helped me to recover those things. So I am not the instrumental of getting all those good quality images.
Thank you.
Yeah, just operation I did, and then, and we have to take.
Yeah, those under ice images were taken in Arctic or Antarctic?
The under ice images are taken in Antarctica. Because we have access to those areas. Arctic also, this kind of similar system is there, but we don't have much access to those icy region.
So Bharati station, near
It is
Bharati
near
station?
Bharati station, yeah.
Okay. Thank you.
Yeah.
In your opinion, what are the indigenization requirements specifically for this application in polar research? Indigenization requirement.
Yeah, I understood. The basic technology we have, like floats and ROV, these are the same thing we want, but we want specific, with specific purpose. For example, I would really want a, what is called sailboat, which tries sailboat. It's just a kayak hanging, and again it has a propeller, and it is following my ship. And I can measure every 100-meter one.
That can be easily indigenous, no?
Yes, most of this technology is very easily doable.
I am not talking about that, like for example, Doppler velocity log. So that is all very challenging technologies. Like that type of technologies, anything you have noticed or?
No, at this stage, nothing particular, because ocean observations, simple technologies are enough. It is putting it in a nice platform, that's it. Yeah, it is a joystick based. But I would really like to have a autonomy where at least the operator, human in the low autonomy, where at least the operator get some feedback, okay, your obstacles are there, etc.
This is just a comment to your question. Actually, if you talk about indigenous, we lack completely when it comes to sensor development and actuator development. Some work in India has started now through the Startup India program, and TIH Bombay recently funded a company called Zalton to do DVL. So they are making an echo sounder and a DVL, which we are yet to. I am from an IO Goa. And then also for actuators and propulsion systems, and these are the ones which are very much critical to indigenize. But from the scientific point of view, your question is more that what is that new thing which you carry down to the under the ice, and we can find something breakthrough. You know, can we carry a mass spectrometer, or what kind of instrument which we don't visualize in terms of just taking photographs, or from the science point of view?
Perfectly for this observatory, CS observatory. Yes. I did not understand your question first. Okay, I would really invest in hyperspectral imaging, because right now we have RBG visual imaging. Hyperspectral imaging does what satellite does to sea surface, and it can be done for under the ice. So that will be something really exciting to do.
What kind of the operating challenges did you face in that particular environment, especially for a Arctic
It is torturous. It's cold. it is difficult because in terms of ROV, our biggest problem is that when we are operating near the iceberg moves, and from far it doesn't look like, but when we go near, it moves, and huge wave comes to the barge which we are using, because the iceberg size and barge size is pretty much same. So that gives a chill. So it would be really nice if it automatically goes there, does the survey and come back, so that our torture is less. Yeah. Thank you.
Yeah, thank you for the presentation. May I request our group director, Dr. Vedachalam, for presenting a memento as a token of appreciation.
May I call upon Dr. R.S. Mahesh Kumar, Director, Center for Marine Living Resources and Ecology, CMLRE. He's former senior scientist at Indian Institute of Tropical Meteorology. He has expertise in atmospheric sciences and ocean-related environmental studies. His research and technical expertise includes marine living resources and ecological conservation, atmospheric sciences and weather radar applications. His major contributions leading to scientific initiatives under Deep Ocean Mission, strengthening marine biodiversity and sustainable ocean resource management, and promoting interdisciplinary marine and atmospheric research. His recent milestone led MOU collaboration with CMLRE and ICAR NGB FGR for deep sea biodiversity research and sustainable marine resource management. Over to you, sir.
Good afternoon all. Actually, I'm not a marine biologist. I'm from atmospheric science. I have been given the charge to administratively facilitate the operational implementation of the schemes of the Ministry of Earth Sciences. So I'm here just to give a brief about what the Center for Marine Living Resources and Ecology does. And afterwards, I'll just go through why this underwater robotics is required for the marine living resources ecology and the observations as well as taxonomical or biodiversity information system to be made for the country within the Indian EEZ. Next slide, please. I'm sorry, my throat is having some issue. Next slide, please. Yeah, this is the Center for Marine Living Resources and Ecology. We are situated in Kochi. It is one of the attached offices of Ministry of Earth Sciences. Next slide, please. So this all started with our lifeline Sagar Sampata, the fisheries oceanographic research vessel, the only fisheries oceanographic research vessel being operated in the country. So this is 1985 onwards. Till 1995, it became, the Sampata cell has become an attached office under then Department of Ocean Development. Afterwards, in 2001, through a Gazette notification, it became a Center for Marine Living Resources and Ecology. So recently, we have just completed 25 years of existence. So main mandate is to systematically document, inventorize, and assess the marine living resources within the Indian EEZ. Next slide, please. So we are, just to give a glance about what are all the schemes being implemented, we have three major umbrella schemes of under the Ministry of Earth Sciences. One is Prithvi. Under that, we have a marine living resources and ecology, one vertical. In that, biodiversity, ecology, ecosystem processes, fisheries, resource and habitat assessment, societal services. So if you see all the above, plus under the Deep Ocean Mission, we are implementing the vertical three the technological innovation along with NIMOT for exploration of conservation, conservation, deep sea biodiversity, particularly the biodiversity of the seamountain ecosystem, so in, over the and island ecosystems. And under the mission Mausam, again to just understand the air-sea interaction and how it is impacting the marine ecosystem in the coastal region. So if you see, all the, most of the, about 90% of our mandate lies with the marine living resources and ecology, where observations and exploration and sustainable exploitation is the main mandate actually. The next slide please. So this is the Sagar Sampada, 42 years old, and with that about 420 cruises we have completed with a large amount of data, samples, and many new findings, new records for the Indian ESC and the new species identification for our region. So we have whatever traditional observational methods are available on board, from CTD, ADCP, and nets, bongo nets, sonars, and ADCP, thermoselenograph, AWS, and all. And this is the green lights, green dots are the areas where these 420 cruises have been conducted. Next slide, please. Generally, the field research facilities on board, all are the traditional systems. Latest one is equipped with a new one for the marine mammal spotting, about 18 nautical miles, a monocular. Next slide, please. So these are all the areas where with what the main results we have found out. One is oxygen minimum zone and seamount ecosystems over the Lakshadweep and this Andaman areas, and particularly spawning and breeding grounds of the fishes, economically important fish breeds we have identified over the coastal waters, means slightly off the coast, so that it will be easier. We are able to give the advisories to the Government of India, and which are all the seasons for spawning and famous for breeding areas. And oxygen minimum zones, dead zones, all were identified over the Arabian Sea as well as the Bay of Bengal region. Next slide, please. So these are all some of the records, new species discovered, as well as the new type localities available over the Indian region. It is mostly all type of fauna, the deep sea fauna have been identified, about 95 new records, new species 48, and the total voucher specimen we have 3480. We have National Biodiversity Authority accredited referral center, where we have the specimens are all collected and kept, and anybody interested in the country to deposit or to collect or to visit and take some information, these are the center is working in that. Next slide, please. And we have normal taxonomy, a classical taxonomical approach, and the eDNA approach, both molecular approach we use for taxonomical identification of the species, and we are having the marker gene sequences, about 570 DNA marker genes generated, and from the sediments, from megafaunal and marine mammals, and from the water samples alone. Next slide. So under the Deep Ocean mission, we have about we had conducted about 9 cruises, and in that 32 seamounts over the Arabian Sea, Lakshadweep area and Andaman Nicobar regions we have found out, sampled, and some partly surveyed. And if you see again, the sampling techniques are adopted, all are the classical techniques. So we need to go for some modern techniques, wherein we are now working closely with NIOT as well as the other organizations and the private players whom they will be helping us to go into the to non-invasive techniques for sampling as well as for the species collection, species identification, as well as for sample collection. Either it is ocean bottom or the water related at different depths. Next slide, please. So this is from the DOME, Deep Ocean Mission thing. We have about identified 201 deep sea ecoreads, 42 which are potentially new to the science, and different assemblage patterns of benthic organisms with a clear geographical variation. And we need to have technological improvements for enhanced sampling efficiency. Next slide. So this is just what are all the deep sea biodiversity, what are all the areas where the habitat and the ecosystem which CMLRE as well as the nation everyone means interested to look into. So these ecologically sensitive zone areas will be identified and they will be helpful for declaring the marine protected areas. So we need the close range observations, large area mapping for close range. So depending upon the observational need and the objective of the cruises, these are all the these two areas majorly concentrated. And we are looking forward to have some of the profiling and the precision sampling techniques which are latest available without disturbing the marine environment. Next slide, please. Selective samplings for eDNA or fauna or microbes with dedicated sampling tools without any physical disturbance. Next slide. So usually this ROVs, towed imaging systems, and landers and AUVs are being looked for. Earlier, very long time back, the whatever ROV developed by NIOT was used on Sagar Sampada for 1 or 2 occasions, but then due to some logistical or technical problems or issues, we could not continue with that, and so now we are looking for the latest available techniques which lightweight and all which can be held, which can be managed by the Sagar Sampada because it is old. Thanks to Department of Expenditure and the Ministry of Earth Sciences efforts in means we are trying to get the two new vessels for as a replacement for Sampada and Kanya in the down the line 3 to 5 years time, and I understand that the ministry is already been the cabinet note or the PIB note is being circulated for the implementation. So these are so baited cameras. Anyway, I think we can discuss later. So what are all the requirements accordingly? Here I am not to project what we don't, whatever we don't have, but what we would like to have the better sampling and in situ observational techniques. Next, please. So manned submersible is for biodiversity observation sampling is one latest what along with the NIOT we are closely working on, and this will have in situ observations of deep sea ecosystems. It has advantage non-invasive targeted sampling, collection of samples from deep sea water, high resolution 3D image, laser photogrammetry for actual dimensions in the live fish or live fauna itself instead of catching them, bringing them on board, and they will be dying, and after that we'll have all the sampling and the details. We can have 3D mentioned itself. Then directly evidence-based observations, the total ecosystem and their behavior, long-term monitoring also. And apart from that, my colleague from NIO also talked about the bio-inspired soft and smart robots, which also can be used for these biodiversity and ecologically sensitive area identification zones. Thanks, that's all I have. Any questions if I have? Okay. That is one of my old photos, you may not be identifying them. I am the person.
See, are you have any investigation or any studies on increase of water pollution near the coastal region? For example, microplastics or other chemical pollutants.
Actually, our sister organization, National Center for Coastal Research, is the organization which does this marine litter, marine plastics and the coastal pollution related. So we are not having any directly in coastal area. We are not into the deep sea only.
Because there was recent report in Vivian Port. So there was one tanker sunk and
Elsa 3 when sank, we had an opportunistic cruise. We were off the shore. So we had all the observations and some report also we prepared. and what plastics and how it is seen in the bodies, as in the stomach or anything of the fauna, deep sea fauna, ocean, what do you call, living organisms. So those were reported. We have the observation. We have submitted to the Government of India as well as the Government of Kerala also.
Oh.
That was it is not the planned one, but the Sampada was around in and around sailing in those regions. So we just moved the ship towards that region.
So also you are identifying the species. So you are looking at it in a manual way, like after looking at the image in a manual way, or are you using some AI tools to...
AI tools are being developed under the Vertical 3 now with the photographs, and we are training a model and non-invasive with the camera. If it goes, then if it is identified, it automatically it will give the taxonomical description. So we are trying. We are in the AI tool is being developed now.
That is in-house development?
In-house development, yes.
Oh, good.
Yeah.
Thank you.
Thank you.
Sir, with time constraint, we'll try to close.
Thank you.
Short of time, sir.
No?
Short of time, actually.
One
Yeah.
question can I ask?
Please, faster.
I'm new about this, but do you have any program on this myctophytes, because they do this vertical migration? Are they of any use can they be counted as resources, because they are so much in abundance? Sometimes they cause like a false flooring for the ship. So you have anything on light to throw on myctophytes?
Myctophytes also being observed. We are doing a midwater trial. Myctophytes, we are doing it.
Can they be counted as resource for us? Is that useful thing?
Yeah, it is. It will be, yes, it is useful. We have the Ocean Biodiversity Information System, OBIS, for Indian Ocean node. So all these eukaryotes, myctophytes, all the fishes and the samples, means all records, new records are being updated. So this is also one of the areas, yes. Yeah.
Thank you, sir. May I request our Deputy Director, Dr. B.K. Jana, to give an token of appreciation to Dr. Magesh.
Now I call upon Dr. Aprajita Sharma, Head Underwater Archaeological Wing, Archaeological Survey of India. Her research focus is on Chinese porcelain in India, archaeology, maritime trade and historical significance. Her research expertise includes underwater archaeology, maritime trade and cultural exchange, ancient Chinese porcelain study, excavation methodologies and museum studies. Her major contribution includes research on maritime trade networks in Indian Ocean region, and our current research focus on scientific study and preservation of India's submerged cultural heritage and offshore and onshore underwater archaeological investigation. Over to you, ma'am.
Thank you, sir. Thank you for the introduction. And good afternoon, distinguished scientists, engineers, officers from Indian Navy and researchers. I'm going to speak on the underwater archaeological expeditions conducted by the Underwater Archaeology Wing, and it would include my recent underwater expeditions and past expeditions, also the methodologies and how we actually do it. So to begin with, India's maritime heritage, we have the largest coastline, 7,500 kilometer, and as you can imagine how much scope we have for the underwater archaeology. So looking at the scope of maritime traditions from the Harappan period onward, we have tradition of maritime trade with the societies like Egypt, China, East Africa and Southeast Asia. The evidence of these interactions is through the ancient ports, shipwrecks, ancient settlements, and the trade routes which we often found through the ceramics and other evidence. The underwater archaeology, of course, it helps to reconstruct the maritime history and cultural interaction. So looking at all these things, Underwater Archaeology Wing was under the Archaeological Survey of India. It was established in 2001. And our aim was to explore, excavate, and document. And then that is why we are engaged in exploration and excavation and conservation or protection of underwater archaeological sites and the capacity building programs through the training of archaeologists. We have recently trained 4 archaeologists in diving also. And also the main part of any archaeological excavation is to present it in front of people. So for that we conduct seminars and conferences, and we of course publish reports and articles. And the collaboration with inter-agencies is very important because archaeology goes in hand with oceanography and other related fields. So the major areas of work are offshore exploration, shipwreck research, our digital documentation, and research and publication. And we also follow UNESCO Convention on Protection of Underwater Cultural Heritage 2001. Although India has not been ratified for the convention yet, we are in process, but we follow all their rules and their rules, which includes in situ preservation, which is very important, and scientific investigations. And recently we have begun the capacity building training program in the ASI, which is divided into 3 modules: theory, fieldwork, and diving. And this was the theory. We have conducted 2-phase program, one for the ASI officers itself and one for the officers from the State Department of Archaeology and university faculty members. And for the fieldwork, we went to Bet Dwarka and Dwarka. We did some snorkeling there also and the fieldwork. And then we did some diving. Now we have trained divers in ASI. For the past expeditions, we have worked at Bangaram Island. It was a shipwreck, Princess Royal. It was a British shipwreck. And for this, we collaborated with the Indian Navy. The ship was at the depth between 9 to 54 meters. And then we worked at Dwarka for tracing the submerged remains, then Mahabalipuram. And in 2009, we did one different study, anthropological study, in a lake called Loktak. It is in Manipur, for the study of old settlements. And then at Elephanta Island, again, we collaborated with Indian Navy to trace the old jetties and the port sites. And of course, we did some exploration at the Bay of Bengal and Arabian Sea. This is the image of Loktak Lake. These are actually man-made dwellings. It's a very old tradition and people build their huts on it. So we plan to study the anthropological study of this region, and these are called actually fundi in Manipuri, which is floating dwellings. And we did some documentation of boats there, the local people, how they make it. And we did documentation. Then in Elephanta Island, we did some work with the Indian Navy. We did diving there also, but the water was really murky due to grazing. And then in 2025, we began our expeditions again. At Dwarka, we have done a very big excavation recently. This began in 2025. At Bet Dwarka,
on the stage to just give a memento to. Followed by this, we will have a small summary of the session, please.
Just summarize the session. So in this session, we have seen subsea vehicles, how they are strategic enablers across security, science, environment, and heritage domains. Based on the demands, there were key observations like maritime security needs a persistent underwater surveillance. Second, in ocean exploration, deep-rated and long-endurance robotic system with modular payloads is again a demand. Third, polar research needs more AI-based capable platforms. Biodiversity assessment benefits.
So may I call upon Deputy Director Jana sir for just giving a memento to or a chair. Thank you, delegates, speakers, and excellent audience. Thank you for the session. Thank you.
To the session chair and co-chair for your time. We shall now break for IT. All the participants are requested to kindly return here by, let us say, 4:20 for the next session. We have very fruitful panel discussion at 4:20 we'll plan and have. We shall break for IT.
Lapel mic 1, 2, 3. Lapel mic 1, 2, 3. Lapel mic 1, 2. Yeah, no.
This session brings together experts to deliberate upon the future priorities, infrastructure requirement, and opportunities for self-reliance. It is a group discussion on technology gaps and indigenous efforts. The panel members are Dr. Y. Srinivasa Rao, Distinguished Scientist and Director General, DRDO. May I kindly request you, sir, to kindly grace the dais. Sir is the chair for this discussion. May I request Dr. T. Santana Krishnan, NPOL, Commander P.K. Srivastava, MOES, Dr. S. Ramesh, NIOT, to grace the dais as well. Finally, I request our very own Mr. R. Ramesh, a scientist of NIOT, to grace the dais as co-chair. Thank you very much, sir. May I now request the co-chair to introduce the session chair and formally commence the session. Thank you, sir.
All is small. Now we can. Good evening, distinguished guests, esteemed speakers and participants. It's a great pleasure to welcome you all to this technical session on technology gap and indigenous effort for underwater robotic vehicles. It is my privilege and honor to introduce our session chair, Dr. Y. Srinivasa Rao. He is a former distinguished scientist and Director General of Naval Systems and Materials from DRDO. So I would like to introduce all the speakers. Dr. Y. Srinivasa Rao he served as Director Industrial and Director General of Naval System and Materials from NSM, and he led 6 major DRDO laboratory in naval and material technology, and he contributed in development of warhead for Prithvi missile systems. He served as a project director for interceptor missile system. Key contributor to mission Shakti interceptor vehicle, instrumental in commissioning INS Avnisha floating test and range ship. So I would like to introduce the next speaker, Dr. T. Santana Krishnan, a scientist G serving in NPOL DRDO lab. He is expertise in ocean optics and defense laboratory, and he contributed in development of underwater optical technology for Indian Navy and applications, contributed to multidisciplinary defense technology and national security projects. And next I would like to introduce Commander P.K. Srivastava is a scientist G from Ministry of Earth Sciences. His expertise in blue economy and ocean governance, and he is a former commander from Indian Navy. He served 20 years for ocean governance, hydrography, deep sea exploration and international marine collaborations. Next, I would like to introduce Dr. S. Ramesh, Scientist G, Deputy Director, Mission Mode Projects in NIOT. More than 3 decades he served for deep sea exploration using a robotic vehicle, and he has participated in all scientific exploration from gas rates, polymetallic node mining, hydrothermal sulfide, and he is the member of Legal and Technical Commission from International Seabed Authority, and also a life member of Ocean OSI. Thank you. Over to Chairman.
Yeah. Thank you, Mr. Ramesh, and thank you all the esteemed delegates over here. The underwater robotics workshop, actually today morning sessions were wonderful. Each speaker, we were engrossed. Each speaker brought out from his point of view at different areas of work. And one thing which I commonly found that we have a lot of strength in-house. The reason might be because other than if you look at from other areas, if you whether we talk land-based systems or air-based systems, in India, Indian Navy has started the design much earlier before anybody else has done. And there was exclusive MTech programs and BTech programs on this. And the naval application schools also have been, and the marine schools have come up a lot in India. This caused, at least the design-wise, we had a strength. Now, in fact, if you are looking at the strategic systems itself, we have now making it everything in almost indigenous. And this is because, this is the strength, whether I call it SDG group or whether it is the L&T as a participant, or the entire Indian ecosystem which is working on that. When we can build that, we can build anything. It's only next level is the automation. So, and in automation also today, if you actually see the underwater area, I myself know about 10 companies speaking about underwater systems. There are companies which Navy has placed an order and they are building on their own a complete swarm-based systems. And we have our own DRDO labs, both NSTL, NPOL and NMRL, also focusing on research. And if you look at from the sonar point of view or deep water areas, we are even speaking about the sensor modules. I'm not talking about the classification algorithm systems. Even at the sensor module level, we have indigenized. And this, most of things went into strategic program, that's why everything is not out. But then the industries that have been developed, whether it's a Keltron or a Mistral, or many industries have developed around it. Similarly, from NSTL, we have both from the land-based systems and underwater systems, the hydrodynamic area, we are absolutely strong. Today, we need not have to depend. The number of volume of database we do have today on the hydrodynamic area, in fact, the next generation, we have given it in just 1 year, the complete data for the next generation. The infrastructure that has been built both from the design point of view and the testing point of view, the model testing point of view. We need not have to go anywhere in the world. That's the level it has been built, and the Indian industry is also supporting it in the same way. And unmanned area, the drones area has taken up like a exponential. Today, every area you go, people say that I'm doing this part of the drone. You talk to any place in this country, they'll say I'm doing drone control system, somebody will say I'm drone optics, so what can translate it to the underwater system? I know that it is not easy, but then there are people working on multi-dimensional areas in the airborne systems, and this has got a potential to translate to I will not go beyond this right now. Let me come back in the end, because we will take the opinions, because each one has got his own expertise today, and what we can give as a feedback to the ministry, that how the ecosystem can be further built, what can be done. I will reserve my thoughts to the end. I will ask, I'll start from there. Dr. Ramesh, you can open the session with your thoughts and process. We will have a brief session among us. We will go among us, then we'll also open up to the audience, because ultimately we have to, collectively we have to give something to the government.
Good evening to all. Thanks to Chairman and then the opportunity given to us. Actually, the technology gaps and then the indigenization, 2 points were given as an agenda for this discussion. And from the morning, we are listening from the initial remarks of our Vice Admiral onwards. There is a need, actually, from the coastline to the deep sea. There are different types of needs are there in the country to look after. If you see, on the coast means there are port development. Then when we go to 100-meter depth, we have the oil and natural gas in the Bombay High. When we go further deep into water, there are resources. Now, India also signatory to the biodiversity beyond natural jurisdiction. And India is having 3 contracts for the deep sea mineral resources. And having the Lakshadweep and Andaman as an island, then we have a larger territorial water which needs a surveillance within exclusive economic zone. By considering all these facts, different type of technologies are needed. So what is the technology gaps we are looking into it? If you see that globally, yes, acoustic is the only medium of communications we can see in underwater. We are having, because in India we have indigenized products like CDAC has done and BEL has done, Keltron has done some of the products. Can the startup ecosystem which is already in place can use any of the sensors means, yes, still the development is in progress only. To strengthen that, there should be some level of policy level decisions to be there to have the funding to support the, from government to the academia to the startup ecosystem. This should be a bigger level of thinking should be there to bring out that facts. If you see in underwater vehicle, if I wanted to develop, the fundamental things are like earlier discussions said, there is a BLDC motor is required to propel as a thruster, and the synthetic foam to keep the vehicle to float. Okay, and then the power modules, high density, like now lithium polymers are coming. So how many industries are there to package it for underwater? And industry needs to be hand-holded for their commercial interest. Actually, NIOT has transferred many of the technology to the industry, but they are looking into a larger volume. Until larger volume comes into picture, these gaps are not getting filled. Still, we are going for importing many of the components and paying by nose. Even the simple launching and recovery system for the ships, if you see, which is maybe mechanically intensive system, which can be fabricatable in the country, but we are going for the importing systems only because of its ruggedness and the certification process and the quality control aspects are there. So 1 or 2 times usage, right now whatever we are having is possible, but when we are going into the real system development, yes, there is a gap available which needs to be identified by intensive investigation within ourselves to fill the gaps. I stop here and then let us continue our discussion. Thank you.
So, Santanan?
Good evening to all. Thank you,
Santanan, you can also throw some light on the NPOL area.
Yeah.
Because many of us are not aware what in deep research technology NPOL is also building up, and the industry that NPOL is building up.
Okay, sir. Thank you, Chairman and organizers for giving an opportunity to participate in this panel discussion. While the topic of the workshop says underwater robotics, and mainly targeted to meet the blue economy plan of the country administration. So basically it is exploration of ocean, resources, one side. So wherever a ship or submarine through their instruments, attached instruments cannot reach the depth beyond certain limits, there is only one way underwater robotics only can go. So therefore, the topic of today's workshop is very, very important. Then while choosing underwater robotics, how long it can go? And the research is very new in this country. Very recent, few years it started. And unmanned is, it is new to be realized. So having said that, where are we today? In technological gaps and indigenization efforts, where are we today? If we think of from my own expertise from a sonar lab, I would list few, any unmanned or manned robotic system has to go down in deeper frontier areas of extreme pressure and darkness, freezing temperature, etc. of the deep water. Sensors is a main thing other than the structural engineering of the vehicle and the propulsion systems. So saying that the sensors and the propulsion system and engineering of the structures or the vessels, I would list some of the sensors basically because they cannot carry like a ship or submarine. Our naval ship and submarines carry a huge amount of sonar arrays. It is very big in dimension, very big in size, and very big in processing, which is kept inside the cabinet of ships and submarines. So such privilege we don't have in AUVs. So we have to have a very smart sensors, thin film sensors, fiber optic sensors. We at NBOL, we are working on fiber optic sensors where it is, the fiber cable. The fiber cable itself, which are deployed in seabeds for communication across countries. Distributed acoustic sensing, now the technology has come, we are working on it. So similar fibers can be fitted on these AUVs and seabed sensors. There should be a communication. It is not only from sea surface, which some of the presentation which we have seen today. There can be communication from seabed arrays, which are deployed for strategical, surveillance purpose of Navy and coastal areas, coastline administrations. So there can be communication from what they detect, can be communicated to this underwater robotics for them to take a decision. Plus there is a surface communication. And to name some of the list of sensors, I can name one is fiber optic laser. Laser sensors, they are very thin and reliable, high sensitive, especially in deep water they are very sensitive because the noise is very less there. Otherwise in our ship sonars and submarines, the self noise of the ship and submarine carrying is also very high. Above that we have to detect other target vessels. But whereas deep water, the noise is very less, it is quite silent. Therefore such sensors, thin film PSATs, single crystal sensors, crystalline sensors, fiber optic cables. Then of course we have to think of when we have underwater bodies and very high pressure, leak sensor for the safety of the safety sensor, many safety sensors for the vessels, things like that has to be looked into that. Then when we develop such underwater bodies, we have to have the infrastructure. Like other countries, we have to have a very high infrastructure level here, and people are talking about now digital twin for certain objects or the passing vessels, and some simulations in our country is going on research, especially in SRM, and some participants are there here. Can we not think of a digital ocean covering some area and allow our vessels to pass across, move across? And what are the things we can, with the cloud computing facility and AI technology what we have, I think that is one area also we should think of. That will help us,
Navy Training School already has the ocean awareness facility.
Yeah.
So if somebody can visit it, you will be aware of that. Now, I just want to interrupt here.
Yes, sir.
See, the sensors and technology, what happens, the volume that we need is very less. If you expect industry to invest on that infrastructure, it's very difficult. What we have to do is actually, we have to take up the case, whether it's through the DRDO route or the INRF route or some route, we have to fund on the infrastructure.
Yeah.
We have to identify industries and we have to give some volume number to them. Let them be just an idle stockpile. If we need only 20, for example, one sonar may require about 30 elements or 64 elements. If some industry has to make one line for 64, it doesn't work out. He has to make some 1,000 numbers to make it. So we have to allow that industry to make it, then only the country, or alternatively, we decide this area we will not unnecessarily get into it. Let the globally somebody supplying, we have a long-term arrangement with him with an MOU or some structure where they will be friend to us for a long time and they will just import them. But today, in current context, we are not able to believe anybody. So it's important that all the critical structural things we have to make it. And why will industry invest into it? For example, if he has to invest 500 crores and makes only 50 crores business on this, it doesn't make any sense, sir. So for him, that funding has to be done, and I feel that national facilities has to be established in these areas. And from their facilities, let the industry come and work on that. Industry can use those facilities to build that. Otherwise, underwater sensors will hit a roadblock.
Plus, this battery areas also, when the water is salt, seawater batteries research has to be given more thrust, plus this eDNA, I was reading some papers, literature, eDNA to identify the actual marine biodiversity.
Seawater battery thrust area also I can comment straight away because you raised this issue. When we opened also, because if a company has to establish a seawater activated high energy battery, he has to invest some 75 to 80 crores. The number of batteries that come out that is used, because these seawater based batteries are used only in a torpedo kind of environment, whatever we do, we cannot hit 100 torpedoes. And it's a long cycle time. And we don't get many of the chemicals for it, nor we, for example, for a aluminum silver oxide battery, I need a motor with a magnet which works at 170 degrees. We are not available because China has stopped that, and we are hitting a roadblock there. So these are the practical issues that are coming with the seawater activated battery. What we have is a lesser energy density battery, and we are compromising on that. And only 1 or 2 companies are ready to invest that much infrastructure, and so it's again hitting into a 1 person or 2 people only, because industry is not seeing business in this area. Basically, industry is not seeing business in this area. So something has to be done. See, we have to economize our combat weaponry also. We have to increase the quantity which with the current situations we have a limited value of funding available, and we have to work in that. So this is a cycle. This is the problem with the underwater. Whereas lithium ion batteries will get even lithium ion batteries you get cells and you start assembling, but they will get volume there.
And last but not the least, sir, somebody asked today when Dr. Vedachalam presents about Matsya 6000, how many such vehicle we have. So when we indigenize technology like this, very complex technologies, we make one, and I saw that the phases, about 5 phases, starting from 25 to 28, it undergoes various tests in the seawater up to 500 meters. Then after 3, say when we actually meet the 5,500 meter in 2027 end or 28 middle, it has already about 4 years. How is its life taken care of? Because it has already met lot of saltwater interactions. So what is the precautions we are taking on? That is also more important from my opinion. Thank you now, and if anything.
Thank you. Good afternoon to all of you, sir. Thank you, Chair. Sir, to my understanding, as we see today, underwater robotics, as we have seen since the morning, has become not only a exploration tool but also of strategic importance. Whether we look at ocean resource development or resource mapping or polar research, or even for biodiversity exploration, environmental monitoring, etc. And in this area, when we talk about indigenization, sir, what we gather right now here in most of the areas is a vehicle integration, sir. That is what we define as indigenization. Whereas the subsystem components are still not being designed or being produced indigenously. They are all being procured, whether it would be the battery systems or the synthetic foams, flotation systems, or even the thrusters, etc. So these are all primarily being imported through the suppliers, through the industry partners, or some of the channels, and integrated into an indigenized system. So if we have to look at indigenization, sir, then we have to go into the subsystem assembly levels, and there the challenge is, as very rightly pointed out by yourself and Dr. Ramesh, the volumes are not there. If the volumes are not there, why will industry or anybody invest in that? So there could be 2 ways of looking at it, sir. One, we could have some kind of a anchor customer or anchor industry which will drive one particular theme, or say it is battery development or floating system development. There has to be an anchor institute or an anchor department which will steer it along with the industry and support it through its programs and funding through the government as well as industry partnership over a long term 10 to 15 years tenure, sir. This could be one option, sir, where the industry sees a visibility for any product to be coming up in the long term, and then they are able to put in some R&D efforts from their side along with the government support to take it forward. A second way forward apart from the anchor investors could be a national program, sir, which could be identification of sub-component level requirements which is driven nationally by, say, any of the research institutions either through DRDO or NSTL or from MOES side, which could then start developing those sub-components at the lower level, which would finally form an indigenous system, sir. That would be one of the other ways how I see, sir, to move forward. This is one aspect which I found was primarily we are talking here again on mostly the hardware part of it, sir. None of us have discussed anything on the software component part of it here, sir. Another great area of lacuna is the software development. We do not have our own indigenous, say, robot operating system software. If we have a swarm of underwater vehicles, do we have the software to control and guide them? We don't have, sir. We still depend on, so that is a software development industry which we need to develop parallelly along with the hardware part of it, sir. Even the underwater AUVs we talk about is going for a way-to-way navigation point of view right now. They do not have mission onboard capability for multi-mission operations. These are simple areas which can be designed in-house by our software engineers or industry partners, which can be taken up, sir. And lastly, sir, what I see from all the presentations and which we have known from the ministry side of you, we do not have indigenous capacity and capability for certification. We are depending on DNV or some foreign certification agency to certify our systems. If we do not develop our own certification capabilities, we will not be able to indigenize it in the long term, sir. Thank you, sir.
Very value and very good points. Actually, in fact, I also noted down this underwater anchor industry. See, I'll just put my thought process because the audience also is there.
Yes.
Anchor industry has to be given certain incentives. The anchor industry, for example, the CSR, the anchor industry is funding all the MSMEs, and it should be considered as a CSR fund. This will help because anyway they have to spend from their profits, the CSR. This will help to grow and the anchor industry infrastructure should be completely tax-free. Something like the revolutionary systems if you bring, then the anchor industry will be interested. Like L&T can invest, Adani can invest, but they will invest if we have incentives. And then the supporting industry has to be given a sustainability model. See, for example, I know one guy who is making in Cochin, no morning, IROV is making the what is making our recovery mechanisms. Now, you are right, one recovery mechanism he makes. The second recovery mechanism is totally different because in sea, everything is different. Now, how many periods he keeps on investing into R&D, he has to sustain. Now, once he invests that, he has to also have people. You are talking about software. With agentic AI coming, everything is becoming an agent-based system. Now, every day it is changing, and these guys will not be there if the work is not there. Forget about salary. And if you do one ship, and second ship comes after 20 years, this guy doesn't have work. So this is where we have to keep feeding. And that way, I have seen CDAC investing in that. And in fact, CDAC is making one own indigenous Indian chip. I feel that chip should come to our underwater system also. I don't know what scale, 20 nanometers or something you're making. That should come to underwater. Then we can put all your edge computing. And what he's saying about ROS, Now CDAC is the best place to make the robotic operating system because you are making anyway the chipset. You make us the operating system, then this will help. So the points which he has brought out is excellent, and we have that capability to do it. And this is need not necessarily to be only underwater. You make a common platform, then we have a market, and from there we can derive the underwater requirements. The image classifications and all will be, the signal processing will be same. Only with the sonar and the electromagnetic waves there may be a little difference of the input signal, but then we have the processes same. So CDAC can be one agency which can actually push such kind of a amendment, and from NSTL point of view also, lot of AI based algorithms are being developed. They can also look at it. And you rightly, like he has also brought about on the subsystem component level. This is where NPL works. This is where we have to work. This is where NIoT comes in. We have to push into the subsystem component level. See, when we have built a vessel, I'll tell you, with the experience of building a vessel, we identify an electrical control system from X company. Now, the situation in this market is so high, we ordered a company in Korea. The next day, the company will see after 1 week, the company is bankrupt. We have to order again from somewhere else. Though the technologies are available, plus we don't have anybody in India making the complete grid structure for an electrical vehicle. We have to depend on them. But on surface we have, underwater we don't have. So what you are saying, what you are saying is this is where we have to work, but these things is possible if we take it up as a strategy. Yes, we will build everything in India, like MEDA servo drives. We said electrical motors should be built by MEDA servo drives. Now some stage has come. We took a strong stance there. These are the things which happen, but I will leave it to the audience. I think some points can come from the audience also. Yeah. There are two hands. One more mic you give here. Captain, hello. One more mic to the. Yeah. You identify yourselves.
No, this is Dr. Samantha from Indian Register of Shipping. Thank you very much for all these panelists to give their perspective on the underwater robotics. I have two queries rather than questions. Dr. Santaram Krishnan, he has mentioned that thing, that why don't we make that digital twin for these systems, whatever we have been developing for these things. For this perspective, I just wanted to say that thing. I belong from the classification society mainly dealing with this ship, may not be directly to the underwater your ROV. We have developed digital twin during construction of the ships, which is already in place, and for the operation, because when we are talking about the digital twin, it is the life cycle of the vessels, because every time I'll be getting the informations from the operations, and if we need to correct it or something needs to be given, that as a classification society I'll be giving the feedback, and in the operation that will be implemented. But there are two things here. As a authority, I can take that responsibility, but I need that informations also on a time basis. So that sensors and all the information has to come there. So there is the lacuna is there. Because the moment I'm asking the owner of the vessels that give me the informations if something goes wrong, so that I can give you feedback that on time varying process that what could be done, that is not, system is not yet developed. But that during construction of the vessels, I have fully embedded that things, because the vessels, when it's getting built, the information is coming on day-to-day basis. Every day we are giving the informations, and if any correction is required, that's why the ship is being built. But when it is in the operations, I need to also get that information. Similarly, if this thing can be done, because right now we have implemented that things in the construction phase, but yet to develop such kind of an automated system in the operation phase, because due to this data is not coming. So similarly, same thing can be done for these underwater vessels also. And then another information I wanted to give you, Commander Srivastava, he mentioned that thing, that certification needs to be done. I really appreciate that things which he has brought into these things. whatever people have been developing all these underwater vessels and all these things, you are doing the research, you are building that thing, but you have to verify based on certain third-party agency who can take the responsibility for the entire system to certify whether it is be running or not. You have mentioned that DNV is, you are taking the help. You must be knowing that thing, Indian Register of Shipping, the National Classification Society of India. We have been all ships in India, even in the foreigns, we are the sole authority in giving the certificate. Why can't you discuss with us and we can also help together ecosystem indigenously make in India to develop such kind of thing rather than you are going to DNV or LR or ABS?
Dr. Samantha, we take that, we know that IRS is the classification society and most of our vessels, everything, though there are dual classifications, even in dual classification cases, we are taking it up. I did, sorry that I should have corrected myself when Dr. Srivastava said I missed it. We accept it.
So there is one correction, sir. Certification for manned vehicle in underwater.
Not there.
IRS doesn't have the certification right now. I'll come to you.
No, those things can, no, those things we can improve.
So
That
we
is
can
what
give
my
a
suggestion. That is what my suggestion was. That when we do indigenization, it means
No,
that.
but all the surface vessels,
Sir,
IRS
we
is
all know, we
giving
know
the
that, sir.
classification.
I
So-
was only pointing out to the.
Yeah, we close the debate. This is not the point where we are giving the gaps. But definitely as a, IRS also can take it as a gap where underwater you can take it up as a new domain expertise in your side where you can, future you can give the certification.
They don't have, correct.
Yeah.
Correct.
So, Captain, you wanted to say something?
Yeah, I'm Komodo Dalbir. I'm from the
Sorry.
Directorate of Submarine Operations.
Komodo?
Komodo Dalbir Singh. What I gather from the discussion is that the gap in indigenization is primarily business sense, scale of economy of scale, because production, nobody wants to participate because scales are not there, orders are not there. I don't think that is really the gap, because if you want to indigenize a niche technology, then I think that is a strategic decision. Government can have its own DPSUs producing something, provided there is a design which is indigenous. Because I see there's a difference between reverse engineering and research. China went on a reverse engineering path, whereas most of the research was happening in Western world. Both have reached some place. A research should lead to some innovation and a design. Once you have a design, then you have built to print things once you want to prove a design. Because Apple has its own design, but chips are produced in China, still it is Apple owns design. So I think the gap is in that innovation and design, where we are faltering in indigenization. And innovation and design can have many steps in between, including certification and prototype development, and development itself is a huge process. So funding of development projects, because the result or the product version, where user comes in interface, that what as a user I don't see happening. That's the gap of indigenization, what I see as a perspective. You are right, private industry doesn't want to participate. Why would he? It doesn't make a business sense to him. But we are talking of a strategic need of the nation, where business sense doesn't mean anything. So it's just my view.
Yeah.
So
I think one of the speaker has actually made this point, where he said some national program kind of thing should come, where we identify all the technology gaps, where we can actually do a core research and fund them. Main important is fund them. For example, if I put up a case, say I wanted a certain type of transducer and it costs 30 or 40 crores, it should not hit a roadblock saying that this 40 crores, what is my return of investment? This is how, moment it gets into finance angle. We are right now, he knows there is a case available where we can do a long range sensing, which one of the scientists and industry, it's a scientist, industry and academia participation, and it is hitting a roadblock just because to say that what will be written on this. These are all strategic decisions. We have to take up a mission mode decisions, like what we took mission mode decisions in some other areas. Same way for underwater, we should create a mission mode architecture which can push, then we can work out. These are for example, I had to develop a specialized power amplifier. I have to develop a specialized sonar. We can identify 10 areas or 12 areas, critical areas, and say that yes, we fund about 10,000 crores onto this in the next 5 years or 6 years. This is what we are doing in other areas. We open up as the challenges, whether it's an IDEX route, whether it's a TDF route, or whether it's the industry collaboration routes. We have got multiple routes now, DRDO routes. We can open up these areas, but it should fall on the domain. So there can be some committee which can look into it and form where we are lacking on this integration front on specific subsystems which as a strategic requirement. You are correct. I think we are 5:15. What we will do is we will take only 2 more questions. I think CDAC will take 1 question, and then I'll come to one of them in the last.
Yeah.
Otherwise, we can listen to everyone, but we have to also conclude.
Yeah, thank you, sir. So basically, there are a couple of points as Chairman Dr. Srinivas Rao sir told. See, if you look at the indigenization in India, these naval systems have done some very advancement. See, I should say around 30 to 40% of naval systems have been indigenized. Why? Because there are 2 things. That somebody at that time, some visionary had thought that we should do that. And in our experience, we got wonderful support from DRDO labs as well as from Navy. Because when we first tested POC or the first model, for example, echo sounder, then there is a lot of errors. Say, we should say the targeted specification, we met only around say 60%. But they are patient. Of course, some of the captains said, you throw this away, I can't do that, we can't tolerate this. But anyway, the top brass have patience and they supported us. Finally, we could make the echo sounder indigenized, the submarine echo sounder indigenized. So we have set up underwater ranges in Goa with the NSTL direction and guidance. And recently we have completed a Varnamala project in which the noise ambient measurement will be taken for submarines, means the external threats. So one aspect I have seen in this thing is especially the power of IFA, even overpowering the director at the DRDO, because sometimes I have seen, because once in the financial angle they will ask so many queries. That may not be technically relevant, but financially that may be a relevant or audit point of view. So in some critical technology areas, we should, how we have to give away with that aspect we have to think of. Then as sir rightly pointed out, the industry is looking for large quantity business. There is no doubt about that. If you look at any country, Western countries, they are all thriving, even if it is strategic systems, it is running on business only. So in this particular case, there is no large quantity, especially in underwater systems. How many underwater vehicles is required in India? How many Matsya is required? Maybe a few only. So also by the customization is required for every application. So that is, I will tell you one example. Sir mentioned about IC fabrication. So we have discussed with we have started dual core, quad core processes. But when we require the strategic requirement, for example, minus 40 degrees Celsius to plus 120 degrees Celsius, then the industry will ask how many quantities. So what finally they agreed, we will make a general IC that will be useful for space application or Army, Navy, Air Force. So all type of applications should cover, something like that. So they are looking for, say, for example, image browsing ICs, everybody is ready because there are a lot of applications are there in traffic or many areas in surveillance. There are a lot of applications. So that is one area. Volume is not there. So there should be definitely support from the government or identify very important strategic areas. Then on NBL side, Sandanesham sir mentioned about fiber optic laser. Sir, what will be the distance we are looking for? Means the distance?
Range.
Range.
In the low frequency, about 7 to 8 kilometer. What?
In laser?
Fiber lasers.
Okay.
We have demonstrated
No, we'll take
some
the
of the
gaps
technology
now.
to.
We'll conclude quickly, because the others are, offline you can have a
Yeah,
discussion.
okay. On digital tin, see, we should also be little careful. In this, AI is good. Absolutely, that is a game changer. There are two types of AI. One is predictive AI as well as generative AI. What we have seen in the ChatGPT is already there are information is the internet, so the data is taken, that is open data, that is generative AI. But in the case of predictive AI, like in the case of we predict the maintenance of a ship or something, so we should be little careful. Means there can be pitfalls. Because depending on the data and the learning, the data learning, that will be means there can be errors. So that we should be the another factor is the indigenization of line replacement units. So we have indigenized multiple LRUs for HAL, Hindustan Aeronautics Limited. Okay, so because there are, I have seen some our major fighter aircrafts are grounded because the outside things are not getting from there.
Rajesh, I think you conclude.
Yeah, I will conclude. I will. So here one
one person also wants to say
only two statements.
No, let him say, but conclude quickly.
Yeah, conclude. Yeah. One thing is, see, the people think that the re-engineering is a simple thing. It is not like that. We have some systems we got in Russian language. We don't know what is the interfaces and all. So it is a very difficult task. It is not like that. So we have to re-engineer, and then only that. The another way is like recently done in submarine case. Have an agreement with a foreign country, a friendly country, and get the TOT of the things. That also can things become more faster. Otherwise, if we are looking for our technology to mature, it will take time. So that's all from my side. Thank you.
So we'll take one from left and one from right. So first left side, any one of them. I cannot decide. You people have decided. Somebody has to come.
You pass your question to him.
So good evening, everyone.
And you quickly conclude.
Yeah.
2 minutes, not more than that.
I think actually I just want to speak about a chicken and egg problem, basically.
You identify
this area, myself, actually, I'm Jagdish. I'm a faculty from IIT Kharagpur, Ocean Engineering Department.
Okay.
So what I'm trying to speak here is that being a niche area, we are not able to produce people, the manpower, in a way what is required actually. One issue is that we are developing technologies, but at the same time we are not able to provide jobs in those particular technologies. We do not have specialized programs as such, and we do not have a synergistic approach wherein actually we train the manpower for tomorrow actually. So what we are currently facing is a dearth of this manpower where we can actually envisage these particular domains and quickly grasp and grow towards how China is growing actually. I think this is one point.
Do you have a solution? Do you have a solution for this? This is a problem every core area is facing. Do you have any idea of solution?
That is what, sir, I'm about to speak actually. So the solution for this is that actually we should have a holistic approach with institution, as I think currently we are doing in industry academia collaboration, like how the projects are coming and this. But this should be channelized in a way that it should be clusterized, that these particular domains, these particular institutions can become nodal agencies, subnodal agencies, and sub-subnodal agencies. This can pass through a sort of a chain, sir. And based on that, we can have a collaboration between ourselves actually. The cluster can identify that these are the set of experts for probably acoustics. These are the set of experts for communication. These are the set of, and so on and so forth actually. So this can be.
So it actually complements what Commodore says. It can complement it. You want to say? Yeah, quickly, because I have to give it he's already having the mic. Quickly.
Good afternoon, sir. I'm Lieutenant Commander Balaji. I'm a manned submersible pilot in Indian Navy. I won't take more than a minute. My point is to add on to Commander Srivastav and Dr. Samantha. Classification, there are two aspects to it that I'd bring as an operator of manned submersible pilot. One is design framework, which is, for example, ASME PVHO standards. Second is classification framework. We need two of those within the nation, and I think we should use platforms like this, the UWR workshop, where brilliant organizations can come together and use this as a stepping stone to make our own standards and classification. because I really believe in collaboration where possible and competition where necessary. Because if we can't do that, then we can't truly indigenize what we have been trying to do all these years. Thank you.
Actually, that's a very good point. We have to collaborate than compete. Competition is only where necessary. It's a very good point. Otherwise, in the underwater domain, we will not be able to give a long-term sustainable models.
Good afternoon, sir. This is Srinivasan from Mazgoda Shipbuilders Limited. Mazgoda Shipbuilders Limited.
Mazgoda.
Yes. Actually, we are the only shipyard in India made 8 submarines, and all the conversion submarines operated by Indian Navy is made by us. Right now, we received EOI for XLUVs. Now, XLUV is totally different from small SOVs, basically. Suppose we see the XLUVs, the endurance, and the endurance is almost 4,000 nautical miles. If you see the 4,000 nautical miles, the battery requirement, lithium ion requirement will be almost 2 megawatt. So there's no any industry is developing lithium ion battery of such huge volume. And if you see the depth also, the material science has to be developed actually. The material for material with the density, if you see the depth is very more. So we have to find the material science also we have to develop. And as an example for this MADA, as you clearly told, this one is a good example for the indigenization. Earlier, MDL is the only yard who involved in indigenization of these MADA motors. Earlier it was told that nobody can make EPM in India, but it is a good example for indigenization. So it's possible for us to make collaboration with more industries as well as academia to develop this kind of new technologies.
So I'll answer from the XLEU point of view. One is material science.
Yes, sir.
DMRL has developed enough materials. Please contact them. Whoever is designing for you, they are doing in silo. I can tell you very clearly who is designing. I know who is designing. They are in silo. So please contact DMRL. We have developed enough materials which can go deep. And the corrosion aspects, yes, we will take care. Talk to DM. Let the guy talk to DMRL. Come. Next is on the lithium ion front. NSTL has already transferred technologies to a lithium company, but you have to look at something in a hybrid model, air independent propulsion or a fuel air cell models, which those also model actually land based system is fully developed. You look at from that point of angle, or a hybrid system where there is a capacitor and a system and a combination of a super capacitor. There is a companies in India which are not doing the super capacitor. They are not concentrating on underwater because nobody is approaching them. A combination of a battery and super capacitor, because you don't require power continuously also. There is a pulse wave mode of power requirements. So please understand your power requirements. That's why I'm saying you work on your distribution and power management system. Then you come to battery. Once you do that, then your problem will be solved. So that XLUV, the size is so huge it can accommodate. So you look at from the design point of view, the shipyard. I know the Navy is helping you, so then you will start discussing on this. Motor also you have to optimize. Your motor also is drawing more power than normal required. These are my first cut points which you can look at it, but because we are doing first time, these are the issues will come, but over a period of time we will gain.
Sir, again regarding the battery, actually we also visited NSTL, they are doing that one. But there are here we need the pressure tight batteries basically.
You give the requirement. You give the requirement, it will come. I don't want to take everybody into that domain now. Yes. Battery is a separate domain. I don't want to take everybody into domain. But it is not a technologically not possible system. Yeah. We have done much more complex than that. Okay, I think we will conclude with this because time is short. See, we don't have an incentive scheme to scientists. We have got incentive scheme to startup. Scientist has to do the role because he is a government servant. This is a system which we have in the government of India.
Sir, IITs have, sir.
Your DST system I cannot implement in DIDO. DIDO has got many strategic works. We do 70% strategic, we do only 30% others. If I start implementing in DIDO this requirement, we will get into bigger problems.
Sir, I think, sir, DST has
got a system, but DIDO system is totally different. We have such a huge load on the strategic system, we cannot do this kind of arrangements.
But through DRDO industry academia interaction, we have 15 centers, IITs.
No, his point is, see, the DRDO scientist gets a patent and he also gets something like what DST can.
Even if you have to patent, we won't.
He can take sabbatical. He can take sabbatical. That system may come. I do not know where it is. But it can be a sabbatical, but he cannot be a partner, or he cannot be in the industry. He cannot be a partner, or he cannot be a shareholder in the industry. It is not permitted in the MOD parlance.
Sir, I want to conclude.
Yeah, we'll conclude now. We'll take off.
Sir, can I say one small
Why it's 5:30? I have to conclude. So many people are waiting. Yeah, okay.
Yeah, sir. My name is Dr. Yogesh Humkar. I'm a faculty from IIT Bhubaneswar. So 2.5 years ago, I have started my own startup out of own funds. And then I was lucky enough to get Ministry of Earth Sciences and IoT project 2 years ago. So what was good about that particular project was that the things that we learned, technology that we have developed as a part of that project. So that thing was useful to our Indian Armed Forces. So we were able to train manpower, and we were able to also deliver it to society. So this may be actually a good thing to do, that you can identify people who are delivering things and who can be given, actually there should be some funding for science development, some funding for the technology product development. That will be helpful to the society.
Today ANRF has got a huge funding arrangements. People have drawn already. Recently Agnikul got huge funding. There's a huge funding coming up in the through ANRF route.
Yeah, and the
people have to utilize it. So we'll conclude it.
Okay.
Now. So you can just conclude what are the points.
So we discussed about the gap, especially the component that we are used in the underwater vehicle, like a propulsion, acoustic positioning system, acoustic modem, synthetic foam, and all the scientific sensors like a multi-beam sonar, suborbital profiler, magnetometer, CTD, all sensors presently being imported from abroad. So we need to have a separate mechanism, like a national level program has to be initialized so that we can develop the sensor for the underwater vehicles.
So
and
we will give one firm recommendation, sir, here. There should be a national level program to identify what are the sensor gaps of the understand, and like what Commodore has said, we should work on the design aspects. We can get realized later. How we realize, we can see, we can give them the first cut, they can import the realization methodology, second cut they can set up here, but this national level of policy should come out. We will recommend that national mission, which one of the lead agencies, NIOT, can take up, or somebody else can take up, and they get the funds and they distribute to the Indian industry on this area, and these technologies come up. So we give a clear roadmap. In the next 5 years, we achieve these 10 sensor technologies indigenously. So this is what the committee mandate will be, and we'll clearly say some X number of funds will be catered for this, only for this development, establishing at least of the proto level, this is established. And proto to scale level, industry scale level, what to be done also be given by these people. It should not end up a valley of death at the proto level. So this one policy statement we are definitely, we will recommend from this, whatever the August gathering has given. Yeah, I am just saying, because as a committee here, we should give some recommendations to the government which he can forward it.
So
Next,
maybe for the hardware.
I am just concluding recommendations, so this will be.
As we discussed the hardware and software part, maybe we can take the CDAC help who can develop the processor, and they can build the custom mission planner for all underwater vehicles.
So here also, sir, one recommendation is, like we have a ROS system, robotic operating system. India's own robotic operating system, we should have our own, sitting on our own chipset. So that we can work on the naval domain. For naval robotics, it can work. So this CDAC can take a lead. We can take a recommendation here if everybody agrees on this.
And
so we will give as a recommendation from committee, which may be useful for you when you put up your government papers. But they should be different. See, today industry does not have time. Everything we want yesterday. If we take anything for decision making, we take 1 year, then implementation will take 2 years, then testing will take 4 years, then the world will give you a new system. So CDAC should come out, next 1 year I will make it. Time is the essence for all these things.
Maybe another point, maybe the anchor industry to maybe like a tax free, or maybe supporting the fund that may be initiated in parallelly for the sensor development under that.
Yeah, it's not sensor development. For entire underwater, marine and robotics, there should be a lead anchor industries identified towards the anchor industries who will be given special provisions. That is, their CSR funding, they can increase or they can give a special CSR funding. Their CSR funding should be allowed for this particular activity. They should be given special, if they are importing the equipment or establishing those equipments, some tax holidays for it. The incentive schemes can be worked out, or a space can be given for them, and they may be given a place where they can fund some 10 MSMEs, and all those things, tax exemptions should be given. If this kind of a incentive is given, and we are given, here also we give a 5-year goal or 6-year goal, saying that how many industries are developed by this anchor industry, and how this anchor industry is transformed into make an indigenous system. So there should be a measure, everything should be a measure and a checks and balance for that measure. So this will be the third recommendation.
And another things, as we discussed, we need to identify the certification agency from IRS. We need to build a code for unmanned and manned vehicles.
Here, fourth recommendation, sir. Like manned underwater missions, we should have the certification agency. Today, IRS is the leading agency. They should also be transformed for the underwater systems, which IRS can take it up as a special case for us. Second point which we have, like we should have a certification standards. This was also brought out by one of the speakers here. There should be a standard, like we have a aerospace standard. We have got a mill standard. India's own underwater and surface water standard, naval standards should be built, and you can give a name, NS name, something for that standard. We have to build a standard.
Actually, from DOT side, okay, I want to inform that we are already in the process of taking all the collaborating agencies to develop the standards for underwater vehicles under the aegis of BAS.
No,
that is
the
Bureau
issue
of
here
Standards.
is, see, once you make the standard, world should accept it.
Yes,
so today, a mill standard, people will accept.
Yes, yes.
Yes, standard, people will accept.
We are working from India side on the underwater systems standardization. I need your help also in that. We'll connect.
Correct. That's why I want to put it as a recommendation to government that these standards have to be built and they should be given a specific name, and we have to see that everybody follows that standard.
Yes.
Yes,
So
sir,
we are putting as ISO standard itself classification
So
of
you
systems.
can take the lead, and
Yes.
NIOT can be the lead lab.
We are already connected on that.
Connected, and we will give it as a recommendation to the government. This is an essential recommendation for this country.
This June itself in Paris, we are going to give the recommendation. So just wanted to mention.
Actually, for underwater vehicles and subsea systems, under the chair of NEOT director, BAS already constituted a committee, and various organizations have been roped in, including IRS. So we are starting the process already, sir.
Yeah, no, I made this statement because this has come out from the people who have spoken here. So we'll make it more stronger as an essential request.
Yes.
I think we have covered most.
So all the points are covered, and we had a very good session. Thank you very much for being a very lively session today. All the best. Thank you.
So may I request the director, NAOT, Professor Balaji, come over here to give a memento to the speaker.
There are no speakers, we are only participants.
Thank you, sir. Thank you, sir, for a highly engaging, productive discussion session. Next, I'd like the Address Director, sir, to present Commander P.K. Srivastava. Thank you very much, sir.
Some of the recommendations
Thank you very much, sir. May I request you to present the memento to our co-chair as well. I request our volunteers to kindly bring a memento. Thank you very much, sir, for summarizing the discussion. With this, we conclude the formal technical program for day 1 of the Underwater Robotics Workshop UWR 2026. Participants are invited to visit NIoT laboratories and interact with scientists on ocean technologies. The cultural program will commence at 6:30 in the NIoT lawn, followed by dinner at 7. We thank you for your active participation throughout the day and look forward to welcoming you tomorrow for day 2 of UWR 2026. Have a pleasant evening. Thank you. Jai Hind. Sir, both I cannot do. I request all the participants who are interested to visit the NIoT labs can be there in front of the podium, or volunteers will come and guide you. Right? Once again, I repeat the information. Whosoever is interested to visit the NIoT lab facilities of manned submersible can kindly